16th World Ocean Forum will be held as a hybrid forum in Busan, the capital of Northeast Asia. Time to listen to the world's renowned marine environment experts to make ocean as uniters. You can participate in the forum in person or online to listen to professional sessions and various events for sustainable development and check the trends of the global maritime industries faster than anyone else. We invite you to the 16th World Ocean Forum to be held in Lotte Hotel Busan for 3 days from October 25th to the 27th.
Busan, Korea is already reaching the entire world, like ocean waves that travel far and wide. It's Busan, the perfect World Expo city, transforming our world, navigating toward a better future.
The ocean is a major source of life, food and livelihoods for 3 billion people across the planet. For over 60 years, UNESCO's Intergovernmental Oceanographic Commission has been working at the heart of the United Nations to generate the knowledge we need to conserve and manage this global marine ecosystem. We coordinate sciences, observations, data, and tsunami warning systems. We deliver knowledge, scientific understanding, and capacities to ensure the ocean is managed sustainably and equitably for the benefit of humanity and the planet alike. As ocean pollution, acidification, and warming grow, IOC's role has become crucial as the UN platform to discuss the increasingly relevant issue of ocean health and climate change, in bringing nations together and fostering exchanges between governments, society, and scientists, as well as in providing to the extended oceanographic community access to data, information, and science. From UN conventions to community-based meetings, we bring to the table authoritative, vital ocean data to inform policy decisions, to support the implementation of the Sustainable Development Goals, and ultimately to harmonize humanity's relationship with the planet. To face a climate crisis of planetary scale, we are bringing together the world's leading expertise, decision makers, action-driven innovators, and engaged citizens around the UN Decade of Ocean Science for Sustainable Development. Join us to co-design and co-deliver transformative ocean science solutions to create the ocean we want. You too can be part of the ocean knowledge revolution.
This is the news at 7 p.m. The new climate report from the UN says that cuts in enough to reduce greenhouse gases. A radical change is needed in how food is produced. That is to say, fewer calories.
We're always told we need to stop. Stop driving. Stop flying. Stop using plastic bags. Stop eating meat. Stop ignoring the science. But science also tells us that just stopping won't be enough on its own. If we're going to save our future, we also need to start. Start thinking outside the box. Start managing marine resources more productively. Start developing more climate-friendly technology for waterborne transport. With innovation, we can rid the oceans of microplastics. The forces of nature are fundamentally sustainable. We must make the most of it. The world needs more ideas. Solutions not yet thought of. This is not the time to stop. Especially now, when we're just getting started.
The ocean has always been a part of us Norwegians. It has provided us with wealth and prosperity, fisheries, shipping, offshore oil and gas. Now we're on the brink of a new digital age, facing global challenges to sustainability, where the jobs we create must support a green future. The solutions to many of our challenges lie in the oceans. But in light of these new challenges, we must learn to adapt in step with change. Ocean Space Center is the key to our ocean-based industries of tomorrow, a cross-disciplinary center for both established and new industries that will bridge the gap between resource and knowledge economy, connect and develop all disciplines within the maritime industries. In Ocean Space Center, simulations and model experiments will run in parallel to prevent accidents and damage to the environment. This is where industry and researchers will develop new concepts for renewable and cleaner energy production, as well as efficient energy consumption. At Ocean Space Center, future maritime transport systems will be created and tested, like autonomous systems that open up new markets for shipping and advanced technologies. This is where our knowledge and experience about materials and maritime constructions put us in the forefront of developing solutions for emerging industries. At Ocean Space Center, Norway's technological advantage will provide the key to sustainable aquaculture concepts and harvesting of species further down the food chain. This is where we develop research and technology that will clean up the oceans and protect our ecosystems while there is still time. Maybe the next great medical breakthrough comes from an organism living in our oceans. Ocean Space Center is both ambitious and essential. World-leading physical laboratories and digital tools, combined with excellent research, will help tomorrow's solutions become reality. The next generation of research scientists and ocean space technologists will retain and strengthen Norwegian competitiveness and develop a sustainable global ocean industry. The ocean has always been a part of us Norwegians. Ocean Space Center will keep us connected in the future.
네, 안녕하십니까. 잠시 후 10시부터 저희 트랙 1 탈탄소 세션 시작하도록 하겠습니다. 참석자분들께서는 장내로 들어오셔서 착석 부탁드리겠습니다. Ladies and gentlemen, we will soon begin track 1 decarbonization session from 10 o'clock. So please come inside and take a seat. 네, 그리고 저희 통역 안내 드리겠습니다. 저희 포럼에서는 한영 동시 통역을 제공하고 있습니다. 통역이 필요하신 분들께서는 테이블 위에 놓인 수신기 사용하시면 되고요. 한국어는 채널 1번, 영어는 2번으로 맞춰주시면 되겠습니다. And we provide simultaneous interpretation for this forum. You can turn to channel 1 for Korean and 2 for English. Thank you. We'll meet you back at 10 o'clock. Thank you. 네, 이제 10시가 되었습니다. 안녕하십니까?
Good afternoon, ladies and gentlemen. Welcome to the 16th World Ocean Forum 2022. We're going to begin Shipbuilding Marine Transport session. We are providing a hybrid forum, which is done online and offline at the same time. And on the website and YouTube of our channel, you can check our session in real time. And we're providing both languages, Korean and English. And on the website, you can check the materials yourselves. And we are also collecting questions as well. So let us begin the World Ocean Forum Track 1, which is shipbuilding, maritime transport, and Track 1 is about decarbonization. Please welcome our chair, Professor Lee Yeon-seung of the Department of Naval Architecture of Hongik University and Director of Ocean Systems and Research Center. Please welcome her with a big round of applause. Good morning, everyone. Welcome to the Shipbuilding and Marine Transport session. My name is Lee Yeon-seung, and I'll chair the session. It's been a while since we met in person, and I'd like to especially thank all the experts and all the participants. I hope today's session is a successful one. At the 16th World Ocean Forum, we are talking about ocean as uniters. So we have two different themes for today's session: decarbonization and digital transformation. And the first session is about decarbonization, the second, DT, third, wrap-up. So based on the previous two sessions, we will have a wrap-up session where we have general discussions. In this Track 1, we're going to talk about decarbonization, net zero ocean for the future generation. And in the shipbuilding and maritime marine transport, decarbonization is a big buzzword. So we're going to look at specific technologies with 6 presentations. So 30 minutes will be given to keynote speech, followed by 15-minute presentations. So please welcome Chairman Shin Dong-sik of COMEC, or Korea Maritime Consultants. And he's going to talk about development and implementation of sustainable CCUS technology and the role of the Korean shipbuilding industry. Just a little bit of background. Chairman Shin Dong-sik is called the father of the shipbuilding industry, and he's been leading the shipbuilding industry of Korea. And he served as the first economic secretary and the chair of the Maritime Committee. And with his will of iron, he made the shipbuilding industry where it stands now. He made a huge contribution to the Korean shipbuilding industry. And with his leading technology in terms of carbon capture, he's still on active duty at the age of 90. Please welcome Chairman Shin Dong-sik with a big round of applause. Good morning, everyone. As introduced, I'm Shin Dong-sik. It's a great pleasure to speak before you with all the distinguished guests. And I'd like to thank Professor Lee Yeon-seung for having me today. And it is a great honor for me to deliver a keynote speech to you. This is a very meaningful session, and the very fact that you have me here today shows that I'm still active in this field, and maybe you chose me because I'm the eldest person in this industry who is still working. When it comes to the shipbuilding technologies, well, I went to Seoul National University in the 1950s, so I'm the class of 50-something. At the time, that was when Korea had seen an outbreak of the Korean War. And I was full of passion, and I wanted to make contribution to the shipbuilding industry. So for more than 70 years, at home and abroad, I was focused on the shipbuilding activities. And looking back, even though I reached the age of 90, when it comes to carbon capture, transport, and utilization, or CCUS, I'm willing to dedicate the rest of my life to CCUS. I believe that this is the most effective and practical technology that we can utilize. And CCUS is something the shipbuilding industry can make contribution to. And also, it's a big challenge and a task for the rest of the humanity. I fully understand that all of you in this room knows what CCUS means because you're experts. But anyway, when it comes to the CO2, which is leading global warming, well, it's about 40 billion tons a year. And in Korea, CO2 is emitted, and the volume is about 700 million tons. So you can tell that we are huge contributors to the generation of CO2 in order to keep limited to well below 2 degrees Celsius. We have to do something right away so that by 2050 we can achieve true net zero. And that is actually the recommendation of the UN IPCC, and that is the foundation that we are all working on. In order to achieve net zero, we can think of photovoltaic energy, renewable energy, and nuclear energy. And you understand that all these are brought up because they can produce zero carbon, but I don't think these present technologies will achieve full net zero. And especially in Korea, we are not very well equipped with facilities for renewable energy. And when it comes to construction industry, where we are heavily dependent on cement and other aggregates and resources, and as many countries are dependent on fossil fuels, achieving net zero using present technologies is not very feasible. This diagram shows how we're dependent on fossil fuels. So when it comes to CCUS, it is about using coal, gas, and at the same time we capture CO2 so that this can be utilized and this can be stored underground permanently. So fossil fuels, after they're used and after they emit CO2, it's basically putting them back where they were. So indeed, it's about achieving true net zero for the ecosystem. And according to Net Zero by 2050 report, the CCUS technology is the most economic and feasible technology for countries around the world. the tables that you see right here was prepared by the IEA and Bloomberg, and it looks at 3 different scenarios. First, using renewable energy sources to control climate change to achieve net zero. For that, we need a huge investment to achieve the first scenario. So just a ballpark figure, but roughly it's an astronomical investment that we need with more than 1,600 trillion won. The second one is using coal and gas along with carbon capture technologies. And in that case, it's about 960 trillion dollars. And the third one is utilizing nuclear power. And how much investment it is needed? 1,380 trillion. So from these figures, you can tell that CCUS can be a feasible alternative. So the IEA, amongst many other technologies, CCUS is seen as the most preferred way or preferred technology. CCUS is not something simple. It's a very big-sized plant project. So regarding the first step, which is the carbon capture process, we're still working on this process. And I believe that this will provide us with an economical commercial model. For shipbuilding, we have this block process for standardization. And with standard blocks, we increased efficiency for shipbuilding, and that led to higher productivity. For carbon capture as well, we believe that the modular approach and standardized modular approach will provide us with greater opportunities. And most of the areas where carbon captures will be done are located in coastal areas. So if we develop standardized systems, I believe that this will become a very profitable area for the Korean economy, where we can be active and have a leading technology on the global stage as well. And this one is a combined cycle power plant developed by Daewoo Shipbuilding and Marine Engineering. So compared to what we see, well, actually we do have technologies and equipment and fabrication techniques to be able to produce such a power plant. And this combined cycle power plants, which are widely used around the world, can be developed further in Korea as well, so that we can play an even greater role in this industry on the globe as well. And carbon-fueled power plants, we have 7,000 of them. And these power plants should be able to capture or remove CO2, but we can't really remove CO2, right? Because we can't remove all the energy sources. So what that means is, for these 7,000 power plants, if we can secure 1%, at least 1% of the market share for the power plants, well, we would need 70 or 700 of these combined cycle power plants. The highest value-added LNG, we have more than 90% of the market share for LNGs. And given the technology, given the level of technology that we have, it's not very difficult for us to come up with such an idea like a floating combined cycle power plant. And I believe that we can play a leading role in this field as well. And in the next stage, which is storage, shipbuilding industry can also play an active role as well. Even though we produce lots of greenhouse gases, we do have facilities to store CO2. Like I said, Korea produces 700 million tons CO2. But actually, what we utilize, what we use at the end of the stage is only 100 million tons. Then what about the rest? The rest can go to foreign countries. In the Glasgow meeting of COP26, COP26, we made a commitment of reducing greenhouse gases by 300 million tons. It's 300 million tons. Out of these 300 millions, if we can export 100 million tons, then that will be a huge figure. So if you think about LNG, it's slightly bigger than 50 million tons. And in order to transport this 50 million tons, we're working with related companies, and there are huge profits involved. But I'm not talking about 50 million tons right now. It's 300 million. It's such a big number. So if we can use domestic technology, using local carbon capture technologies, and if we carry this to Southeast Asian countries, for instance, then the demand for vessels will be huge. And that will be a very profitable business for 3 major Korean shipbuilders. So that's why these major shipbuilders built this concept for dual carriers. And also, they are trying hard to obtain AIP, or approval in principle. So about net zero, and in achieving net zero, there are so many things that shipbuilding companies can do. And CO2 coming from industrial plants, it's not just the only source, but we also have CO2 from vessels, and actually the volume is huge. We have about 100 or 120,000 vessels around the world. And these vessels produce 1 billion or 1.2 billion tons of greenhouse gases annually. Of course, we can't get rid of all these, and of course, we have to turn to alternative fuels, including LNG, ammonia, and so on. But up until that time, we have to keep operating these vessels, and we would need a mandate to capture carbon. So we had a presentation, and we listened to the case of Panacea, how it is developing carbon capture technology and trying to commercialize this technology. So regarding capturing carbon from vessels, as you may well know, IMO developed indices and regulations, including EEDI, EEXI, and so on. So it's not just IMO, but also the EU. We're seeing stricter regulations going forward. in the future, in order to tackle future challenges, we have to think about this 3D. It's not just the theme of today's conference, but the first D, which is decarbonization, is a big, huge topic. Second D is about different technologies and different industries, diversification. And the third D is digitalization. It's about how we can digitalize, diversify, and decarbonize. In the shipbuilding industry, when it comes to decarbonization, digitalization, and diversification, we cannot wait further to take actions. For decarbonization, we are developing and working on eco-friendly alternative fuel for vessels, carbon-free fuels, and also advancing onboard carbon capture systems and green marine hydrogen and so on. In the field of digitalization, we are talking about autonomous vessels, marine robot mobility, and smart green ships. And this is led by CRISO. In order to increase efficiency, we need to dramatically improve resistance efficiency. And in order to improve efficiency in a drastic manner, we have lots of R&D projects around smart green ship projects. For diversification, we're talking about floating airports and floating cities, and we are seeing the development of scalable technologies for these new concepts. And for VLFS, very large floating structure, we have seen lots of progress in the field of studying this VLFS. And the city of Busan is considering Kadokdo as a floating airport. And I believe that this can be a very feasible and meaningful approach. So the efforts of the last 2 decades will bear fruit after all this hard work. In order to achieve all these objectives, this is the R&D vision that we need and we came up with, as you can see on the slide. And led by CRISO, these activities are seeing progress very actively. So this particular table is actually developed by CRISO, and I stole it. Well, my apologies to Chairman Kim Boo-gi for stealing the slide. But anyway, I talked about many things, many different aspects and technologies that we can use for CCUS. And that was led by many passionate people. And going through the transition, we believe that we will develop our shipbuilding industry to the next level where we can actually lead the world logistics and net zero activities. And by making a huge contribution to this field, well, we used to be a fast follower, and we wanted to catch up with all the advanced nations around the world, but we were not happy with stopping to be a fast follower. And now we want to be a first mover. And by being a first mover, we want to make sure that Korea shipbuilding industry stands at the top of the shipbuilding technologies. So I'm talking about we don't want to be a fast follower anymore, and we want to be a first mover. So I'd like to thank all the passion and creativity of yours. And based on your passion and creativity, I believe that we are able to see this sustainable technology like CCUS. So as long as time allows, I'm willing to play my role to make contribution. I design ships, and I founded this company, Korea Marine Consultants, and I designed more than 2,000 vessels, and also I did the supervision of these ships as well. So when it comes to the future vessels, we will always have this issue of CO2. And that's why I took interest in the issue of carbon capture. And I was very much interested in the development of technologies for carbon capturing around the world. I almost in real time, I monitored all these technologies and technological development. I'm greatly interested in CCUS and leading technological developers because in terms of economics and safety, there are these leading companies and leading academics who are leading this technology. And today I wanted to touch upon more practical and more specific issues because at the same time, while we are sitting in this room, but at the same time, around the world, there are more than 10 conferences dealing with the topic of CCUS around the world. Unless we tackle the issue of CO2, the globe will become extinct. But even though we talk about it a lot, we do not really hear about what actions we took. But what matters is the actions we take. Have you ever heard of a story where they actually successfully captured 1% of carbon at least? That's what we want to hear. So the company I'm involved in is the company Carbon CCS, based in Oslo, Norway. And this company has more than 100 patents when it comes to carbon capture. And it is well prepared for delivering related projects. And since 2001, I've been working with this particular company based on close partnership. So this is a quick introduction to this company, Carbon. It's not an amine-based technology, but it's about using hot potassium carbonates, high temperature, high pressure-based carbon capture, and highly pure CO2 can be captured. This is a highly efficient technology of carbon. This can be applied not just to CO2, but it can be used for SOx, NOx, maritime compounds, and other pollutants. And this can also be used for the oil and gas industry in the US and widely recognized by the BAT. And on the basis of this source technology, across the overall CCS stages, we are working hard on commercializing and implementing the CCUS technology. So if we focus on the core technologies, regarding the CO2, in a stable and economic manner, how can we capture it? And second, about the captured carbon, how can this be safely liquefied, stored, and operated? Third, the captured carbon can be transported through tank lorries and other vehicles. So the next one is about handling this captured carbon. And this is related to building economical carrier for CO2, building economical CO2 carrier. So if you think about the size of CO2 carrier developed by 3 major Korean shipbuilders, it's about 40 or 30,000 tons. But in this particular company, Carbon, it's a jumbo-sized CO2 carrier of 187,000 tons, and it applied for an AIP from DNV. So if the approval is given, then compared to 40,000 tons, it can be much more economical. And next, about capturing carbon and how this can be stored in a provisional manner in the vessel. That's about onboard carbon capture storage. And next one, about utilizing captured carbon and how this can be stored, how this can be injected. Many people might think that putting it underground or into the sea is not that difficult, but it actually is a very challenging task, and we need lots of safety measures to make sure that it is done safely. So this table is what I wrote, what I prepared. And in order to achieve net zero, it's not just about capturing carbon, but we also have to think about well, first we have to capture carbon from a host plant. For that, we needed technology. And after that, with the carbon captured, we have to liquefy carbon. And we need loading, unloading systems. We need CO2 carriers. So across the whole value chain, the technologies should be able to cover all the activities across the value chain so that this can be put into practice. So if one step faces a glitch, then we wouldn't be able to move on to the next stage. So working with the Norwegian company, I thought that I could be a technology provider, and also across the value chain, all these are independent processes. These processes should be optimized, integrated, and orchestrated. By achieving this, once we achieve the harmonization of these independent systems, then we can see the full, complete value chain. And that will require huge investment. And also regarding development technologies, in order to secure funds. For instance, it's not just between governments, but it can be also a back-to-back guarantee systems so that we can finance this technological development. So at my old age, well, it's not really about trying to earn more money, but what I want to achieve, what I want to see is to become the best world-class CCUS player. And I want to see Korea becomes the best player in the field of CCUS. Up until now, CO2 was seen as waste, but now we can see it as a resource. In the US, it started to see it as an asset, not a liability. And the US is turning this liability into an asset. And the project that requires the biggest volume of CO2 is EOR. So from a depleted oil field, well, literally it's depleted, but still 20 or 25% of the field is still there in a solid form. And if we put CO2 into this, then it becomes softer and we can pump it out. So this is the example of North Dakota. By putting 1 ton CO2, this shows how much more we can take out of this field. So the incremental recovery was 155 million barrels with EOR. So the price for CO2 is between $80 to $100. Let's say it's $100 for the convenience sake. And given this incremental recovery, well, it's about $500, which can be more profitable with this technology. So even though the demand for CO2 is a fixed figure, we need much more CO2, which is 156 billion metric tons. So by utilizing CO2, we can create wealth. That's what this table, what the slides are talking about. So once again, I walked you through the technology that we developed and how amazing this can be. Then you might be wondering what would be the commercialization status. So this is the 150,000 ton grade vessel. And this is the Oxy group. And this is the contract that we're pursuing. And this is a 6,000 megawatt plant. And we can capture 48 million CO2 a year, and it required 5 billion, which is a huge investment. So that is the level of funding that we secured in the US, and this facility will be complete by 2024. So on the basis of this project, we can use this as a benchmark and have expanded projects in Korea as well. So I might be running behind my time, but I'm trying to say that we do not have much more golden time left. It's time for action. So instead of just having discussions around the tables, instead of just having armchair theories, having pros and cons, now is the time to deliver. In December, we will have the CCUS conference in London, and this is the theme of the conference in December, time to deliver. We have to stop having discussions, having lectures, but it's time to deliver. So under the circumstances, I believe that it is indeed meaningful that we are here together with all the experts, and this is a meaningful effort. And it was a great pleasure for me to speak before you as well. I hope you can be warriors for the climate change. And that was my keynote speech, and my apologies for running behind my time. Thank you very much.
네, 감사합니다.
Thank you, President Shin, for the carbon neutrality. The most realistic option is CCUS. I hope that this becomes a global and universal technology. And next, we have President Kim Boo-gi of CRISO, who will present the topic, Development of Decarbonization Technology in the Age of Digital Transformation and Challenge of Cooperation. After completing his bachelor's in naval architecture from SNU and a PhD from the University of Michigan, he has worked at the American Bureau of Shipping and has served as an executive at Samsung Heavy Industries with extensive academic knowledge and industry experience. He is member of the Presidential Committee on Carbon Neutrality and is at the forefront of offshore renewable energy and decarbonization, shipbuilding, marine, and transport sectors. Please give a welcoming applause.
이혜성 교수님 감사.
Thank you, Professor Lee, for the kind introduction. Good morning. I am the president of CRISO, a government-funded research institute. My name is Kim Boo-gi. And globally, for the decarbonization and digital transformation of the global shipping industry, this is also a challenge for the shipbuilding and ocean areas. So I would like to present on the development of decarbonization technology in the age of digital transformation and challenges in cooperation. The order of my presentation is as follows. I will start with the global mega trend or digital transformation, how it relates to decarbonization, and the technical measures for IMO's GHG reduction strategy, relevant technologies, CRISO's efforts, and also future plans. And in the second half, I would like to present the zero carbon fuel and international cooperation for the production and bunkering infrastructure for zero carbon fuel. I would like to start with the global mega trend in decarbonization. As you are well aware, in 2018, the IMO released the GHG strategy with the goal to reduce GHG emissions from international shipping by at least 50% by 2050 compared to 2008 levels. At the MEPC recently, the mid to long-term strategy for GHG reduction and initial strategies are being discussed, led by the EU and other technological advanced nations. By 2050, we want to reduce the net emissions, which is also called net zero. MEPC session 80 will finalize the strategy next year. As you all know, in order to respond to the GHG emission reduction in international shipping, we need low carbon and also carbon-free fuels. In the shipbuilding and maritime areas, green transformation and digital transformation are accelerating. But with zero carbon fuel technologies being developed for hydrogen, ammonia, and other clean energies to be developed and fully supplied, this will take a long time. So Norway, Netherlands, and other technological leading nations, before adopting zero carbon fuels, they are developing low carbon technologies, a bridging technology. Digital technologies are used to increase operation efficiency and ship onboard CCS technologies, which are a few examples of bridging technologies. Next, let me go into the technical measures for IMO GHG reduction strategy. Earlier, as I mentioned during the previous part, in order to respond to the IMO strategy, there are three main technologies to be used. First, as you can see on the left, there is the LNG, methanol, biofuel, and other low-carbon fuel technologies. Secondly, there can be the bridging technology, such as ammonia, or at the far right-hand side, there's a zero-carbon fuel technology, such as hydrogen and ammonia, and in the middle, there's the bridging technologies. Up until zero-carbon fuels can be fully adopted, we can use, along with low-carbon fuel technologies, these bridge technologies. So in the short term, medium term, and long term, we can respond to the IMO strategies with these main technologies at every step of the way. Let me go into the crucial efforts for decarbonization in relation to the global mega trend. Here are the main technological areas we are working on. As you can see in number 1, we have a fully electrified car ferry with removable battery system. This is fully developed and will soon be launched. Liquefied H2 are some of the technological areas that we are working on to develop. And in number 2, well, there are many alternative fueled ships under development. We also have we will have plans to build a 2600 DWT marine testbed ship. This is number 2. This is currently being designed. The marine testbed is a fairly new concept, and soon in Egypt at the COP27, we will present a U.S.-Korea joint research plans using the marine testbed ship. And this is being designed. It has not been built yet, but many countries are showing interest, and we plan to engage in joint research. And also, we are developing an independent low carbon fuel and green H2 development platforms. The fully electrified car ferry has a removable battery, not an embedded battery. So the battery will go onto the truck, and the truck will replace the battery if they are fully discharged. This is because unlike US, North America, or EU, we have a very strong tidal power, and we have a long coast. So the batteries, if they are attached to the ship, can be harmed. And so we have been adopting this very world's first concept of removable battery system. This is a slide that you saw earlier during the first presentation. We will continue to work towards decarbonization. And by 2050, we have a full roadmap in place. In the medium term, ship onboard CCS technology, data network AI-based operation optimization will be used to reduce carbon intensity by 40%. And this is the focal area for system development. And also to reduce carbon intensity by 70%, zero carbon fuel development, SMR-based vessel development are also the long-term research areas that we will be fully tackling. In not only developing technologies, CRISO will also use the technologies developed to work with shipyards and other relevant organizations to respond to the international standard development and also to respond to the IMO regulations. And now let me explain the low carbon, zero carbon fuel, and also the bridging technologies and the key technology that we have at CRISO. Starting with the low carbon fuel technology. We have successfully developed a 500 cubic meter level of bunkering vessel for supplying LNG to LNG vessels. We have recently held a naming ceremony. Bio and renewable carbon and other low carbon fuels with the support of MOF as in MOF core technology project. We are working on developing this and also on building a research hub for low carbon fuel. Ammonia, H2 are the zero carbon fuels that we are working on to develop. Ammonia's bunkering system, green hydrogen fuel storage and supply system are where we have achieved approval in principle. And the ship propulsion system, offshore power plant, are some of the areas that we also take great interest in. And the liquefied H2 tank that you see in the middle has recently, at the 2022 H2 meet, received the highest grand prize and received much interest from Korean companies. And we believe that this will soon be technologically transferred. We are also very interested in the SMR and offshore green hydrogen development and supply chain. These are some of the other areas that we are looking into. Next, we have green ammonia, hydrogen. Before all these zero carbon fuel technologies come into play, these are some of the bridging technologies that we can use to respond to IMO. Technologies to improve ship operational efficiency are being done, and you can see on the right-hand side, we are developing a software of different equipment at the Digital Twin Center, which is a running title, which is also being built. And on the board, we want to liquefy CO2 and store it on ship as an onboard CCS. This will be going through a demonstration next year. Biofouling issues and other pollutants that attach to the ship need to be removed, and we are looking into the relevant technologies. And we are also looking at how to reduce GHG. Lastly, for international cooperation on production and bunkering infrastructure of zero carbon fuel. The zero carbon, low carbon fuels and bridging technologies, for them to be commercialized on ship, we need a full development of production and bunkering infrastructure for zero carbon fuel. Zero carbon fuel with the highest level of advanced technology is ammonia. DNV will have in 2025, around 2025, they predict that the first demonstration for ammonia to take place. But green ammonia production and bunkering infrastructure will take a long period of time. Globally, total amount of ammonia production is 185 million tons, but each country develops their own for their own consumption. And only 18 million tons are globally traded. For ammonia to be used as a full-fledged vessel fuel, we need much more production of ammonia, and therefore this needs a bunkering infrastructure and production infrastructure as well as supply chains. IMO MEPCS is looking into the life cycle system for ship fuel. This means that ammonia and hydrogen and other zero carbon fuel production should come from renewable energy sources. Along with the fuel propulsion system development, key zero carbon fuels will need to be developed and supplied globally through a global supply chain. Governments, shipbuilders, research institutes, ship owners, and classes, and international organizations must together work towards that end. Thank you very much.
네, 김부기 소장님 감사.
Thank you very much. In order to decarbonize, he talked about eco-friendly ships and vessels and various types of vessels led by Chris O. Please welcome Chairman Kim Kyu-bong, Head of the Maritime and Safety Affairs, Kim Kyu-bong. He studied nautical science at Korea Maritime and Ocean University, and he studied logistics at the graduate school of the same school. And he worked in this field for more than 20 years in Hyundai Merchant Marine, and he served as the CEO of HMM PSA Newport, and currently he is responsible for maritime affairs and safety. Please welcome him with a big round of applause.
안녕하십니까.
Good morning, everyone. I am the Chief Maritime Officer of HMM, Kim Kyu-bong. Before I begin my presentation, I would like to thank Chair Professor Lee Yeon-seung and other distinguished guests for having me today, and it's a great honor for me to join you in this session. As you might well know, when it comes to the topic of decarbonization from a shipping company's point of view, this is a very important topic. Regarding decarbonization, I'm going to talk about what thoughts and challenges shipping companies are faced with related to this issue of decarbonization. So this is the table of contents. Majorly 3 issues. First, greenhouse gas regulations. Second, in tackling the GHG regulations from a shipping company's point of view, I'm going to talk about our activities and strategies. And then I will wrap up my presentation with conclusions. I believe you already know the GHG regulations. You know the status and you know what kind of regulations we have. In 2018, IMO announced the GHG roadmap, and it specified the reduction target, and based on this target, EEXI and CII will take effect starting next year. Regarding EEXI, I think you already know this. So before, we used to apply the target to existing ships, and that was expanded to cover new ships built. Starting from 2023, you should be able to qualify or meet the targets regardless of the status of whether you're an existing ship or a new ship. You should be able to meet the target by the time it takes effect. And this CII is a very thorny issue for shipping companies. This is about grades, different grades for vessels from A to E. And if you have grade E or D, which means low efficiency, then these will be regulated. And the CII requirements are getting stricter every year. So even if you started off as an A grade, well, you're bound to go down in terms of grade that you get. So that's why it is so difficult. So, for example, this is 13,000 TEU vessel, and this is an assumption that this will be operated on an as-is basis, and this shows how the grades will differ going forward. So if you stick to the existing way of operations, it starts with B, grade B. It starts with B, but in 2030, it will be D. And in the mid-2030, you can see that this goes down to grade E, which is the lowest grade. And if this vessel is an LNG, and if it uses LNG, then for a long time it can maintain the grade of A. And by the time it is abandoned or discarded, this can be degraded. In order to achieve higher grades for CII, the best way is to control the vessel speed. So from CII grades, in order to maintain the C grade, this shows the speed that we have to pursue. So if you're using existing fuel, it's about 20 knots per hour. And we have to reduce the speed by 0.5% every year. And by the time the ship is out of service, it has to be lowered by 10%. And with that speed, you can't really think that your business will be running as normal. On the other hand, if you use alternative fuels like LNG, you can see that the speed remains more or less the same. So looking at CII, you can tell that only from this category, you can already tell that fuels have to be changed in order to tackle IMO regulations. Next shows what strategies and activities are done by shipping companies, namely HMM. At my company, well, this is the greenhouse gas emissions. HMM generated 5.5 million tons last year. And 90% of this, which is 5.4 million, is from ships that are being operated. So we have this reduction target by 2025 compared to 2008. We have this reduction target of 60%, which we achieved earlier than scheduled. And by 2030, we have a target of 70% reduction. And even though it sounds like an ambitious goal, we want to be carbon neutral by 2050. At HMM, these are the specific strategies. So regarding IMO greenhouse gas short-term measures, first with EEXI, more than 80% of the global merchant fleet do not meet these EEXI requirements. And at HMM, 33% are not compliant with this requirement. So the maximum torque will be reduced for these particular vessels in order to meet the requirement. And about CII, we are taking a more strategic approach. First, we do the monitoring of real-time CII, and also we are working on developing a simulation tool for monitoring CII. And for vessels with lower grades, we can think of energy-saving devices, ESD, instead of just reducing speed. And also we can think of using biofuel. So basically we're considering many options to achieve CII requirements. Next, about alternative fuels, low carbon or carbon-free alternatives. And in order to build vessels using these alternative fuels, 2 container ships, 7.7 KTEU level, they are being built. And for those new built vessels going forward, these will be using alternative fuels, including methanol. And from 2026, we are considering the use of ammonia for these new built ships. And I believe that hydrogen can also play as an alternative. And for the existing vessels, based on the feasibility study outcomes, we are considering retrofitting them to use LNG or methanol. And in order to operate these vessels using alternative fuels, we need to secure fuel supply chains, whether it be LNG, methanol, ammonia, and biofuel. We are seeking to build strategic partnerships with suppliers so that we can have a stable fuel supply chain. We're also very active in the field of R&D. For instance, developing onboard hydrogen fuel cells and R&D projects led by the government. We are involved in these projects as well. And we also have a collaboration projects with industry leaders. For eco-friendly shipping, we are actively participating in global initiatives as well. We joined the Getting to Zero coalition, which is working to develop the first CO2-free vessel before 2030. And also, we participated. We are considering the possibility of participating in the Green Shipping Challenge as well. We will be expanding our eco-friendly businesses going forward, including the eco-friendly projects. By 2026, investments of more than 15 trillion won will be made. And that plan was already announced. Next, conclusions. Many shipping companies are well aware of the importance of decarbonization and trying to change their modus operandi to meet the requirements. But it is not always easy to implement these strategies because we are faced with uncertainty going forward. But we have to think about what the biggest uncertainty is. According to the British shipping media, there was a survey that looked at shipping companies around the world, and it asked what the biggest risk would be for the next 5 years. And the regulatory uncertainty was the first thing that came to the minds of respondents. So for shipping companies, regulatory uncertainty is the biggest issue, and that is one of the factors that makes us hesitate in action. About a month ago, between Korea and Denmark, there was a forum on decarbonization. And in this forum, well, the Maritime Authority of Denmark said regulation is key driver of innovation and new technology. I fully agree with this sentence. So the directions of regulations are also important. It's not just about how strict a regulation is, but it's more about the directions of regulations, because shipping companies can make judgments and decisions based on the directions. We have participants representing the government, the industry, and different institutes, and I believe that it's a time for us to join forces in tackling this issue. Last, when it comes to decarbonization, of course, we have this digitalization issue on the one hand, and between digitalization and decarbonization, there are commonalities, but also there are differences. I'd like to touch upon some of the commonalities. The shipping company at HMM and other shipping companies have to tackle these big challenges in order to survive. If we fail to do so, then we can't really maintain our business. My presentation was rather brief, but I hope that it was a meaningful opportunity for me to touch upon the major topics and challenges. Thank you. Thank you very much for your presentation. Chief Maritime Officer Kim Kyu-bong talked about decarbonization strategies of HMM and also challenges posed by IMO regulations. Thank you.
And now we move on to the port presentation. This is the fourth presentation after the shipbuilding and transport sectors. Vice President of Management Jin Kyu-ho of BPA will present the topic Green Busan Port Construction Plan. Mr. Jin acquired his master's degree from Global Logistics and doctor's degree of Port Management at Korea Maritime and Ocean University. From the Korea Container Pier Corporation to the BPA for 25 years, Mr. Jin has been active in port logistics as a port expert. Please welcome Mr. Jin with a big round of applause.
네, 반갑습니다.
Good morning. As introduced, I am Jin Kyu-ho, Vice President of Management of the Busan Port Authority, BPA. I am grateful for this opportunity to speak to numerous experts about the green port policy of the BPA at this huge forum. It is a great honor, and I would like to thank the organizers and the 24 members of the planning committee and all the staff for putting together this event. I would like to first start with a brief introduction of the Busan Port and move on to the BPA Green Port Policy. So this is the BPA. BPA was enacted in 2004 in January based on the Busan Port Authority Act. We have 3 HQs, 2 business units, 260 employees with an annual budget of 1.2 trillion won, mostly in new construction of new ports, reconstruction, and hinterland development. This is the role of the BPA, as mentioned before. Our roles include Busan Port construction, operation, and management, redevelopment of aging ports, and the development and operation of the Free Trade Zone Hinterland Logistics Complex. So our mission is to contribute to the national economy by fostering Busan Port as a competitive hub for shipping, port, and logistics. So this is the current status of Busan Port. Last year, as of end of 2021, Busan handled 22,706 KTEUs of containers. That's the 7th largest in the world. And we were the number 2 in the world in terms of transshipment container throughput with 12,273 KTEU. 30 million TEU are handled globally, domestically, and 75% of that is handled through Busan. So it is the Korea's #1 port, and it was global number 2 in transshipment after Singapore. And this is just a chart showing our global status. And this is the port facility status. As you can see, there is the North Port, New Port, Kamcheon Port, and Daerepo Port that is a part of Busan Port. So the North Port is quite old, and it is the major regional hub connecting to China, Southeast Asia, and Japan. The New Port is the main transshipment hub for global shipping companies. 95% of all cargo are containers. New Port handles 70% of that, and North Port about 30% of that. And Kamcheon Port mostly handles bulk cargo. And next, I would like to go into the green port activities by the BPA. So the speakers before me have already mentioned this, so let me skip this slide. And in step with the global trend, domestically, we have enacted a special act. And accordingly, we have set up a comprehensive plan, and different relevant organizations are implementing the plan. And accordingly, the BPA also set up the Busan Green Port policy. The BPA in 2019, in order for the sustainable coexistence and development of Busan Port and local communities as the vision, we set out the target to achieve 70% reduction in PM emissions from Busan Port by 2025. So divided into different sources of pollution, we have the 4 major areas: ship sector, unloading equipment, green energy, and other environment-related tasks. If you look at the performance, as of compared to 2018, in 2020, PM 2.5 emissions from Busan Port was reduced by 45%, which is 2 years ahead of our plan. Let me start with the vessel. We are installing an alternative maritime power facilities, or AMP. For low pressure AMP, we have 78 of them. And high pressure AMP, 2 new port areas and 2 north port areas in 8 berths. 20 SPOs have been fully installed. Right now, they are not being fully utilized yet as of now, and in order to bolster the use of AMP, we are offering discounts for entry and exit fees or providing other incentives. This is the port guide ship that we own. We are shifting from diesel to electric propulsion system for these ships. Early next year, we are looking at completing the construction. We have invested 1.1 billion won, and this is the very first ship of this kind in Korea. The government is pursuing carbon neutrality policies, and the 140 government ships owned by the MOF and 40 other ships will be fully, by 2040, shifted to a zero-emission fuel. We also have the operation of low-speed navigation area About 20 nautical miles from port, ships that operate low speed below 12 knots, we offer a discount on entry and exit fees. Maybe many global shipping companies use the port and they receive the incentives, and the port plans to expand the incentives in the future. This slide is the LNG bunkering facility. Since 2019, we have started this plan. We do not yet have an actual on-site project yet, but with the new port construction master plan and the fourth national port basic plan, we do have this as part of those plans. So the BPA has conducted a feasibility study and also the co-gas as well. But in our view, the fuel supplied to the ships, it's very unpredictable whether the main fuel will be ammonia, hydrogen, or LNG. So we do think that we need to wait and see and look at where the trend is going, and then consult with the relevant government organizations to either build an LNG bunkering facility or a combination of different fuels. And next is the cargo handling equipment. We're done with the vessel part. There are yard cranes and yard tractors that fill up our ports. So starting with the yard tractors, we have 684 yard tractors on port, mostly diesel fueled, and we want to shift them to LNG. About 66% is complete, and this year 50 more units have been converted to LNG. And by 2025, our plan is to complete this switch with the BPA and government, each taking up 25% of the bill. The private sector takes up the rest, 50% of the project cost. Let me remove my facial mask. My apologies. Next. There are those yard tractors with less than 5 years remaining in their life cycle. So it is difficult to switch those vehicles to LNG. So we instead attach a DPF, diesel particulate filter, to reduce emissions, and this will also be completed by 2025. Next, of using electric-powered yard cranes. Next to the crane, there's the yard tractor that works right side by side with the crane, and we want to develop a unmanned charging station for our MGC, but we need the technology to further develop to shorten the charging time or to enable the tractors to operate for longer hours after full charge. This is the yard crane, and there's the transfer crane and yard crane. And for the new port, all the cranes have been switched to electricity. But for the north port, out of 121 units, 85 have been converted to pollution-free electric cranes. And the rest will be completely converted by 2025. As mentioned before, for TCs, transfer cranes, for some of the cranes that have only a few years remaining in their life cycle, we will attach DPF. This slide is about shuttle carriers. So Busan Port does not have many shuttle carriers, but they are transferring containers on the yard, and they are diesel-based. We are switching to an LNG hybrid shuttle carrier, just like a hybrid vehicle. So the electric batteries are charged and used on these carriers. Next is green energy. Out of the projects we carry out, there is the hinterland logistics complex development in the free trade zone. 850,000 square meters will be developed by 2030 and rented out to private companies. 50% of the project is complete, and this area is being provided to companies in Korea. About 3,000 jobs have been created. About 2 million TEU of cargo is being handled here. So in short, this is a logistics center. And using the rooftop of the buildings, we want to develop and install PV facilities to reduce GHG emissions and also to power the logistics center. And some of that revenue will be used to provide support for the underprivileged class to give back to society. And this is about using seawater heat for cooling and heating. Seawater in the winter is 5 to 10 in the summer is 5 to 10 degrees cooler than air and 5 to 8 degrees warmer in winter, and we want to use this temperature difference to power cooling and heating. And this is actually in use. We can save 25% of fuel cost and reduce emissions by about half. And going forward, well, hydrogen-powered trucks are not yet commercialized. But in preparation for hydrogen vehicles, we are going to install at the Newport and Northport hydrogen refueling stations. And for other port area environmental tasks, port emits lots of PMs, so we use suction vehicle or sprinkler vehicles to sweep the area along with other relevant organizations. And I'm not sure if you can see this slide, but around the port there are red dots indicated on the map. These indicate the locations of PM measurement stations. So we have PM monitoring systems that give a traffic light signal to indicate the level of PM. We had 4, but we have now installed 21 or 25 of these stations to give information to our workers and citizens. Any information collected will be built into a big data database for use in future policy development. And there are many office buildings in the port terminals, and there are many cooling and heating stations there. And we want to use a low NOx burner. The burners have actually been fully replaced with low NOx burners that has led to 84% reduction in NOx emissions. Next is plastic resource circulation. We have an IoT recycling separator, about 4 of them in the coastal passenger terminal, international passenger terminal, and so port offices. So plastics are recycled and upcycled into different products that are then distributed to the underprivileged class. And for passenger ships that come to call to port, we can have plans to install IoT recycling separators there as well. And finally, for 3 years, on the left you see sodium light bulbs. There are many of these towers, and because the port operates 24/7, there are 4,200 of these light towers across the port, and over 3 years, we are fully replacing these bulbs with LED light bulbs. This will be completed by the end of this year. The operating companies can save cost, reduce emissions, and also for the workers, it is better for the safety of the workers. So that was a short introduction to the Green Port Policy of BPA. The eco-friendly policies are a stepping stone towards our path to carbon neutrality. in the process of operating ports, how we can reduce GHG emissions is really where we are looking at to achieve in this policy. And in May, at the IEA, I read that different nations, 196 nations around the world, even if they were to fully achieve carbon neutrality goals, the carbon emissions will still remain at about 2.2 billion tons. So by 2100, the temperature of the Earth will rise by 2.1 degrees. And I think this is really an urgent call for a major innovation around the world and a participation to reduce emissions. And last year at the MOF, the carbon neutrality roadmap was presented along with the vision to as carbon negative by 2050 in the ocean sector. So going beyond carbon neutrality, we want to reach carbon negative. And there are 5 tasks presented, including the port area. And starting in May this year, along with the government, we are building a comprehensive plan for carbon neutrality. Unfortunately, in the port sector, carbon emission measurement criteria is not yet in existence. So we want to develop such criteria and set a target so that by 2050, we can achieve carbon neutrality with the cooperation of relevant organizations. The Busan port, I hope, will lead the way in global ports for carbon neutrality. And with that, I would like to conclude my presentation. Thank you very much. Thank you very much, Vice President of Management Shin Kyu-ho of the BPA, for your presentation to the citizens and workers. You are presenting a pleasant environment, a nice place to work with green policies, and I can feel your resolve. Thank you.
Next, please welcome Executive Vice President Kim Tae-hyun of the Korean Register. He's going to talk about decarbonization and digitalization, the game changer for maritime industry. He studied naval architecture at Inha University, and in the Korean Register for 27 years, he's been leading many activities around R&D and ship inspection. He's serving as the Vice Chair of the Korean Society of Marine Engineering, Vice Chair of the Society of Naval Architects of Korea, and also External Director of Research Institute of Maritime and Medium and Small Shipbuilding. Please welcome him with a big round of applause. Morning, everyone. Thank you, Professor Lee Yeon-seung, for the kind introduction. Just you mentioned, I spent 27 years in the Korean Register, and also including my college years, I've been in this field for more than 30 years. And we're seeing drastic changes, and it's very bizarre, or it's not always usual to see all these kinds of challenges. So after the Industrial Revolution, I believe that we are going through the biggest change ever. Today, the theme of my presentation is GHG regulations and alternative fuel technology. And in order to tackle the regulations, we have this concept of alternative fuels. So I will share more details with you about this. So there are 4 issues that I'm going to tackle. There are 4 sections, but there are many. Just to give you a big picture. Well, of course, you already know the timeline and the contents of regulations. If you look at the red graph on the left-hand side, the graph shows that as of 2018, there's about 1.1 billion tons of CO2 produced by the shipping industry around the world. That means that 3% of the CO2, the total CO2, is from the shipping industry. In order to reduce this figure, well, Chairman Kim Boo-gi already talked about the bridge technology, and we also looked at different technologies to achieve the target. But after 2018, even though we had huge efforts in reducing these numbers, they remain pretty much the same, and actually they are on the increase across the globe. So what these increasing numbers means is the 2030 target of 40% reduction suggested by IMO will not be achieved based on the present technologies. And in the case of the EU, which is leading the regulations in a sense, they have this Fit for 55 compared to 1990s. They have the target of 55% reduction by 2030. And this Fit for 55, for shipping industries, there are two relevant issues, ETS and Fuel EU Maritime. ETS is an emissions trading system. In order to produce emissions, you have to pay for them. And Fuel EU Maritime is covering the cycle of fuels that will take effect from 2025. In order to achieve these targets, and regarding the IMO regulations, well, already our presenter from HMM touched upon regulations for existing ships and new ships, and reductions are required for existing ships in particular. And in operating our vessels, it means we will see more intervention, EEXI, CII. These are the regulations that come into the market, and also this market-based measure, which is the ETS, will come into play. And throughout the cycle of vessel fuels, we have this concept of well to wake that forces us to be carbon neutral. So this will take effect starting from 2023, one by one. So it's a very heavy topic, and this is an immediate challenge that we have to respond to. So for these challenges and requirements, we're bound to try to find some answers to these challenges. So the bridge technology, as President Kim mentioned, we have this technology and other technologies to deal with this topic. Speed reduction to produce less CO2, and the generated gas, how this can be filtered mechanically and chemically, and also using fossil fuels, adding additional technologies to meet the requirements. Well, we have different approaches, but if you look at stricter regulations, there seems to be a limitation in terms of meeting these targets using present technologies. So what's in light blue shows alternative fuels. So it can be seen as a bridge technology, biofuel, bio-LNG. These are the various types of alternative fuels we can turn to. And in the field of alternative fuels, well, you already have seen this kind of graphs. So this is based on the Clarkson's research. Let's assume that there are three types of scenarios: existing fuel oil, LNG fuel, and last but not least, zero carbon fuel. So by 2050, zero carbon fuel will take up 30% of the orders, and the conventional oil fuels may not be existent by 2030. That's what it says. So when this graph first came out, not many people shared their ideas. Not many people agreed with this idea. But as we're approaching 2030, we can resonate with this. So starting from 2020, you can see that actually there are different types of fuels being used. When it comes to alternative fuels, there are many of them, starting from HFO. Starting from the second row, you can see that there are many different types, and we have to consider different physical properties, energy density, and so on. And considering energy density, that means we need a bigger capacity for storing this particular type of energy sources. And regarding alternative fuels, we're going to look at two different types. First, methanol. This was not highly popular, but last year, a very big shipping company, Maersk, placed an order for 12 container ships. So methanol caught many people's attention. Unlike other alternative fuels, this can be handled at room temperature, and its engine is already proven. So these are the advantages of methanol. But still, well, methanol that is extracted from fossil fuels cannot be used, so it really depends on how we can create green or blue methanol markets. And next, biofuel. It's not based on fossil fuels, so it does have values as carbon neutral fuels. And we can blend this with existing fuels to meet the targets of 2030. And for existing ships and shipping companies that use existing ships, they're very interested in biofuels. Next, net zero sources, which doesn't contain carbon at all. And the examples can be ammonia and hydrogen. So in terms of R&D, we believe that this can be commercialized in 2 or 3 years. And we are making preparation for the use of these net zero carbon fuels. But for ammonia, we have to consider energy density because it's related to tank capacity and also toxicity and its high auto-ignition temperature. And as it produces NOx, we need to find more ways or answers to dealing with ammonia as an alternative fuel. In the case of hydrogen, it's very difficult to use in the gas form, so it has to be a liquefied hydrogen. And it is liquefied at the temperature of minus 253 degrees Celsius, which is much lower than that of LNG of minus 162 degrees. So the materials for the fuel tanks have to be developed first to use it as an alternative fuel in a full manner. In introducing alternative fuels, this is basically creating a new path because this is something that we haven't done before. In terms of technology and operation, this is a whole new concept. And as we can see from the media coverage, accidents happened because these technologies that were related in these accidents were something that were not used before. So with that in mind, in participating in the technology demonstrations. And in order for these technologies to stabilize in the field, we are diversifying R&D activities. And as you can see from the slide, we specify these different codes, international codes like IGC code and IGF code. And we are raising voices so that we can be heard by the international organizations. And all these details can be found in the technical documents that we published, and we submitted these technical documents to international organizations. And when it comes to hydrogen, it's actually catching attention from many industries faster than ammonia. We do have preliminary standard and draft ideas, but for hydrogen, we might need some more time to make this concept more detailed. My last slide is about decarbonization, and is it something that we can avoid? Well, actually, this is not something we can avoid, and we have to be ready for the transition towards decarbonization. And the technology for decarbonization is already in the shipping industry. I studied naval architecture, and I already studied all the relevant dynamics, and with the introduction of eco-friendly vessels, I believe that affected the curricula of Korean universities. So these technologies are already reflected in the curricula of universities and in the industry as a whole. We already looked at previous presentations, and we talked about how different parties, including shipping companies and the industry and R&D experts, can play their own roles to join forces because they have different ideas. And for these technologies to settle in the market, we need systems and regulations. First, we have to have clear ideas as to what the future directions of regulations would be. And I hope the government can provide us with guidelines in our journey towards decarbonization. So I already mentioned this 3% versus 97%. In order to reduce this 3% figure, we did lots of research. But also we have to think about this remaining 97% CO2 coming from the land. The key behind decarbonization for this 97% is also held by the shipping industry, I believe. Developing vessels and LNG carriers, ammonia carriers, developing all these different types of vessels and CO2 carriers, these will be crucial in reducing this figure of 97%. So starting from decarbonization technologies toward more effective and eco-friendly technologies for transportation, I believe we can make a better contribution. Thank you. Thank you very much, Executive Vice Chair Kim Dae-hun. He talked about the game changer for maritime industry. Thank you very much for your presentation.
And now, this is the final presentation this morning. We have Mr. Stavros Hatzigrigouris, Marine Consultant and former Managing Director of Maringas Maritime of Greece. The topic is on the seaborne transportation of LNG. Mr. Hatzigrigouris was the Managing Director of Maringas Maritime until 2020 and is a member of numerous national and international shipping bodies and committees. Since 1995, Mr. Hatzigrigorius has visited Korea every year, supervising the building of 150 vessels, and so he calls Korea his second home. Here is the global shipbuilding expert, Mr. Hatzigrigorius, on video.
큰 박수 부탁.
Please give a big round of applause.
Everybody. My name is Stavros Hatzigrigoriis. I have been working in the shipping industry for the past 40 plus years, and I have been responsible for the construction of more than 160 ships in Korea, mainly in the SME. Today's presentation will talk about the seaborne transportation of LNG. LNG, as you know, is one of the shipping sectors that is booming at the moment, unfortunately because of the war in Ukraine and the disruption of LNG supply through pipelines. These are the contents of the presentation. You can read them. I will go through them in the next slides. Apologies for using a very old LNG picture on the right-hand side. This slide is showing what is the current import and export capacities for LNG. The red line is for export, the total for export until year 2034, projects that have been already announced. The green line is the import capacity, the total import capacity. As you know, as you see, there is a gap, a considerable gap, meaning that in case more LNG is needed, more gas is needed to be transported by ships, new export terminals should be built. What you can see, sorry, what you can see on this slide, and sorry for going back and forth, the left-hand side of the slide shows how complex the LNG transportation is, from how many ports LNG can be exported and in how many countries, and they are not all the countries there. In how many countries it can be imported. On the right-hand side, you can see the market share for LNG imports for a number of countries, including the development over the past 2 years, 2021 and 2022. As you can see, China is the biggest importer, Japan is coming second with a slight reduction in LNG imports, and South Korea is coming third. What you can see in this slide is the variation of Russian import in Europe. As you can see, the import has almost halved from 390 million tons in January 19 to about 200 million tons in January 2022. The basic reason for this, as I mentioned already, is the war in Ukraine. What you can see in the lower part of the slide is what we call export volumes that may be at risk, and the export volumes that will be delivered for sure, unless there is another major interruption. Here we see what is the current network of pipelines in Europe, and of course there is a tendency to increase the length of the pipelines because now gas can be imported in Europe from other sources, not from Russia, but from FSRUs all over Europe. This is showing the analysis of the current LNG fleet. As you know, as you see, it's about 600 ships trading and about 230 ships on order. This means about 27%, a little more than 27% of the current fleet is on order. This is unique and shows how much interest is in ordering and operating LNG for the next few years. This slide is discussing the LNG propulsion, the type of propulsion that we use on LNG vessels. You can see that there are at least 5-6 different propulsion systems. Steam turbine is the older fleet with 227 ships in operation and 8 ships laid up. Then we have the diesel electric, second biggest fleet, with 166 vessels. Then we have the slow speed direct propulsion. And what you can see, the 49 ships, what you can see is this is a special breed of vessels that were built between 2006 and 2008-9, that they have slow speed engines. They cannot burn LNG, they reliquefy the vapors, and they will be in big trouble when the EEXI regulations are coming into force. Propulsion technology for LNG carriers, as I just mentioned, we have the traditional steam turbine. This is boilers with a pressure of about 60 bar, a little above 60 bar, and the conventional steam turbine. Then we have a few ships that are trading mainly in Japan, ultra high pressure steam, about close to 100 bar. This is a technology that has been used by the navies of several countries and also in LNG vessels in order to improve the efficiency. Then we have the two-stroke HFO diesel engines that I just mentioned, then diesel-electric propulsion, then two-stroke slow speed, both with the diesel and the Otto cycle. And the future plan, if it goes through, is gas turbine and diesel-electric propulsion and four-stroke direct-driven engines for smaller sizes LNG vessels. The principle of developing the LNG propulsion technology was the ability to burn the boil-off gas. And this is natural evaporation, and the management of boil-off gas is a techno-economical decision. The master of the ship has to make a decision every day on how to condition his cargo, how many LNG vapors to consume in his engine room, and if he has to increase the speed, if he has to slow down the ship in order to arrive in port, in the discharging port, with the minimum loss of vapor and an acceptable pressure in his tanks. Lately, systems are being installed to condense again the vapor and reduce the amount of vapor that is available for using on board the ship. Propulsion technologies, this is the conventional low pressure steam technology, has been used since the early 1970s, maybe late 1960s, and the efficiency is pretty low, it's only about 30%. Then we have the ultra high steam, as I mentioned before, efficiency goes up to 36%. How can I call them? The elephants of the LNG fleet. They cannot burn LNG, they have to use reliq to condense whatever vapor is generated on board. Diesel electric, a large number of four-stroke diesels, coupled with generators, transformers, frequency converters, and finally reduction gears and the propellers. More modern technology, high pressure LNG injection, gas injection onto the main engine. Efficiency goes up to 51% with the gas injection pressure of approximately 300 bar. For these vessels, we need a high pressure compressor, normally a piston compressor that can be used on the main engine, and it is also used in the reliquefaction system. Otto cycle engines, efficiency a bit less than the diesel engine propulsion, but quite simpler plants to operate. This is the kind of boil-off gas compressor that the Otto cycle engines are using. The number of stages has been reduced to 4, down from 6, because finally the required pressure of gas for the Otto cycle engines has gone down from 17 to 18 bar down to 14, 15 bar. Several other options are available for the Otto cycle engines. And this is the future. Gas combustion unit producing steam and a steam turbine and then diesel electric. These vessels can be optimized. If the system is optimized, they can run at a pretty high efficiency, but if the load is different from the optimization point, then the efficiency will go down quite a lot. This is a table showing which are the best, the comparison of the various propulsion systems and the steam systems, as I mentioned above, because of the low efficiency, they are not in the game anymore. In my personal view, the choice today is between MEGI and XDF engines and possibly direct driven, not with reduction gear, with smaller four-stroke engines. This is a concept that is being developed today. boil-off rate, quite important when we run LNG vessels. It's a kind of monopoly. It's only one company that is producing cargo containment systems today. It's GTT, a French system. You can see how the boil-off rate has been reduced over the years, and it is important to reduce the boil-off rate, because then our hands are free to deliver more cargo to the consumer. And as you know, cargo today is required, desperately required. There have been attempts by other companies and even by GTT to introduce new systems, but all these attempts for the time being seem that have failed. I include in this failure list the Mark V system as developed by GTT and the KC-1 system as developed by COGAS. Other entities like shipyards that have said that they will produce their own system, for the time being, they are not doing so. I don't know if it is the cost or if it is the design risk that may not be acceptable to them or to their clients. This is explaining again, there are basically two types of systems today. One is the system with two invar membranes. Invar means that the length of the steel is not changing with temperature, and for insulation they use boxes, basically with glass wool, but panels also, PU panels can also be used. The other system is the Mark III Flex and Flex Plus system. They use PU foam, panels of PU foam. They have one corrugated primary barrier, and then they have a triplex, as they call it, which is a kind of plastic and aluminum foil material that can be used as the second barrier. It is the IGC code that requires all ships to have two barriers. And this is a slide showing how we can take advantage of the liquefaction system, as I mentioned above, to deliver more LNG to the clients. Liquefaction technology, there are quite a few different technologies. The requirement is that these systems should be able to treat whatever excess gas is generated on board, or if for financial reasons, commercial reasons, the vessel has to use fuel oil, and today a lot of ships are using fuel oil, to be able to reliquefy the majority of the cargo to deliver it to the client. This is a slide that I like very much. It is showing how the propulsion efficiency of LNG vessels has been improved over the past 18-20 years. You can see that we started with, if we take the steamships as the base at 100%, the MEGI vessels can operate at 47-48%, and the XDF vessels at 50-51%. This is much more than what is required today for the vessels to achieve by 2030, which is 40%. But of course, the starting point for the new regulations will be is from 2016 for new ships and a bit later for existing ships. According to the CII regulations that I believe you know about, the performance, the emissions generated by ships have to be reduced by a small percentage every year of operation until 2026, when the requirements for the CII will be revisited. Future technology, and this is related with slides that I will show further on in the presentation. Air lubrication system as in fashion, better anti-fouling paints, and shaft generators. The shaft generators, if used in conjunction with air lubrication system, can provide benefits of up to 7-8%. Tank insulation technology is improving. Spark-ignited engines, as I mentioned before, may be introduced, and we have a number of energy-saving devices like rotor sails, hard sails, ducts, fins, etc. Batteries and fuel cells are in the horizon, but before batteries, I believe the carbon capture technology will come into our life. Carbon capture is to separate the CO2 from the exhaust gases of the engines, and either liquefy it or convert it to powder and deliver it ashore for handling and treatment, or for sequestering. Sequestering is pumping the captured CO2 down to exhausted oil fields or to cavities where the CO2 will stay forever. There is a project that is going on. It has been going on since 2017. This is the Nord Stream project in Norway, Northern Light project in Norway. And I believe the results that the Norwegians are getting are pretty fascinating. FSRUs, there is a lot of discussion about FSRUs today. FSRU is a quick solution to gasify the LNG cargo and pump it ashore at the pressures of 100 bar or similar directly to the pipelines that are distributing LNG in several countries. These are the FSRUs. This is a list showing the FSRUs that are available worldwide, and this is showing the capacity of the FSRUs versus the year of construction. And this is showing the companies that are involved with FSRUs, not many companies that will take the risk to have as charterers governments or state utilities. It's a difficult business, but it's happening today. It used to happen in not so much developed countries. Now Europe is in need of FSRUs because the gas pipeline volumes are being reduced. And this is a list showing the number of FSRU projects that are under development in Europe. Methane slip is an issue because it's not only CO2 that is damaging the planet. It's also other substances like methane that has a potential, a global warming potential much higher than FSRU. It can be around 25 if a 100-year cycle is considered, but it is much more if a 20-year cycle is considered. This is a problem related to four-stroke engines, and I show in this slide what Himsen, who are one of the major manufacturers of four-stroke DF engines, are doing to control methane slip. According to what they say, they can control, they can reduce methane slip down to 15% of the methane slip numbers that we see today. Similar action is taken by WinGD because methane slip, I wrongly said before that it's only for four-stroke engines. It is also for Autocycle two-stroke engines. And WinGD are trying to reduce the methane slip from their engines by about 50%, 40% at low loads and 44% at high loads, 47% at the operating load of the normal operating load of LNG vessels. Wärtsilä, who is the other major manufacturer of four-stroke engines, they are doing the same, and they are saying that they can reduce the methane slip of their engine down to 1.0 grams per kilowatt hour from the 1.8 grams per kilowatt hour that we see today. They say they can even achieve lower methane slip values. Development of containment systems, as we discussed. As I showed before, we started from a value of 0.15% of the cargo that you are carrying per day, and this is going down with new systems, can go down to 0.085 or even lower, or even to 0.07% per day. This is an important area for improving the operation of LNG vessels, and the GTT are doing their best to achieve better numbers. Air lubrication system, there are basically two types of air lubrication system today. One is injecting air bubbles to the bottom of the ships. There is the company that started this is Silverstream. The company, but all major Korean yards have their system now. With this, and if combined with sub generators, we can have savings of the order of 7 to 8%. The cost of electrical power that you need to drive the air compressors that you need for the ALS systems is about 30% cheaper if you use the sub generator than if you use the four-stroke diesel generator engines of a ship. There is a second type of air lubrication system. It's called passively aspirated air lubrication system. It's under testing today. it consumes much less electrical power than the standard ALS systems, but I have no idea, and I believe, as you see, water is flowing on board with from the bow of the ship, and this may cause an increase in the propulsion power that will be needed to power the ship at the same speed. Then they are using ejectors to create the bubbles. Variable frequency drives, I think this is something that all operators should consider to install. You can reduce your electrical load of pumps and fans and similar equipment down to 40% of the existing installed power by using systems that can reduce the RPM for the rotating machinery by using electrical solutions. The amortization for these systems, for what I have seen, can be very fast, maybe 1.5 years for the fans, and maybe around to 3 years if the pumps are fitted with VFD. Exhaust gas economizer for diesel generators. It is again in fashion. You can get free of cost steam instead of having to find the auxiliary boiler and produce the steam that the ship will need by using fossil fuels. Rotors, a lot of discussion about rotors, a lot of potential, but you have to be very careful on how the rotors are installed, if there will be problems entering ports, below bridges, if you have cranes working on above the vessel, it's something that will come. It's coming, by the way. I was talking with somebody the other day. They say that they have more than 100 orders, rotor orders, for bulk carriers. Stabilization system. I've never understood why these systems are not being implemented in the LNG industry. They will reduce the roll, and by reducing the roll, they will reduce the BOR, and they are not expensive systems. If there is a problem with CAPEX, you may consider to delete the bow thruster of the ships. I think more than 50% of the LNG vessels that are on order today do not have bow thrusters. Anti-fouling technology, a lot of discussion, a lot of different proposals by the paint companies. I think we have to spend money on better paints because we get them back from the daily consumption of the ships, and now we have the EXI and the CII to deal with. Shark skin paints. It's a paint. There are actually membranes that resemble the skin of a shark. Air is trapped on the skin, and this is reducing the friction between the sea and the hull of the vessel. It has been applied on smaller vessels until today, but I believe there is some potential there. Future challenges, increasing asset prices. In 2018, the price for an LNG vessel was 170 million. Today it's 245. Extended delivery times. Most of the yards now are fully booked until the end of 2026, and some of them are offering berths for 2028. It's a volatile market. Nobody knows what will happen when the Ukraine war stops, and I hope it will stop. As I said in the beginning of the presentation, we need new liquefaction projects. We have to deal with the methane slip, and I had some slides on this. And of course, we have a new regime in Europe, which will expand in other places of the world related to carbon tax and carbon trading. Thank you very much.
네, 현장
If on the LNG supply and demand, we were able to hear an in-depth presentation from Mr. Hatzi Grigoris, although he couldn't be here with us on site. So that is the end of all 6 presentations this morning. The decarbonization technology for shipbuilding, marine transport, and on the international cooperation, I believe that we have had a very broad discussion. Despite the tight schedule, I would like to thank all presenters for their wonderful presentations and all participants this morning. And with that, I would like to close the 2022 WOF Shipbuilding Marine Transport Session Track 1 on decarbonization. Thank you.
네, 발제자분들.
Thank you very much, all the presenters, and Professor Lee, thank you for chairing the session. So the shipbuilding and maritime transport will continue after the lunch break with track 2, digital transformation, and track 3, wrap up. We will continue our discussions after the lunch break. We will have an hour and 30-minute break, and we'll meet you back at 1:30. And at 1:30, we will begin the digital transformation session. Thank you.
네, 그리고 현장 연사자
And for those who are in the room, presenters in the room, you can go to the 42nd floor for your lunch. Enjoy your lunch, and we will meet you back at 1:30. Presenters can move to the 42nd floor to have lunch.
I have a quick announcement to make. The luncheon is prepared on the 42nd floor of the same building. So you can go to the 42nd floor and enjoy your meal. Thank you very much.
The 16th World Ocean Forum will be held as a hybrid forum in Busan, the capital of Northeast Asia. Time to listen to the world's renowned marine environment experts to make ocean as uniters. You can participate in the forum in person or online to listen to professional sessions and various events for sustainable development and check the trends of the global maritime industries faster than anyone else. We invite you to the 16th World Ocean Forum to be held in Lotte Hotel Busan for 3 days from October 25th to the 27th.
Busan, Korea is already reaching the entire world, like ocean waves that travel far and wide. It's Busan, the perfect World Expo city, transforming our world, navigating toward a better future.
The 16th World Ocean Forum will be held as a hybrid forum in Busan, the capital of Northeast Asia. Time to listen to the world's renowned marine environment experts to make ocean as uniters. You can participate in the forum in person or online to listen to professional sessions and various events for sustainable development and check the trends of the global maritime industries faster than anyone else. We invite you to the 16th World Ocean Forum to be held in Lotte Hotel Busan for 3 days from October 25th to the 27th.
Busan, Korea is already reaching the entire world, like ocean waves that travel far and wide. It's Busan, the perfect World Expo city, transforming our world, navigating toward a better future.
The ocean is a major source of life, food and livelihoods for 3 billion people across the planet. For over 60 years, UNESCO's Intergovernmental Oceanographic Commission has been working at the heart of the United Nations to generate the knowledge we need to conserve and manage this global marine ecosystem. We coordinate sciences, observations, data, and tsunami warning systems. We deliver knowledge, scientific understanding, and capacities to ensure the ocean is managed sustainably and equitably for the benefit of humanity and the planet alike. As ocean pollution, acidification, and warming grow, IOC's role has become crucial as the UN platform to discuss the increasingly relevant issue of ocean health and climate change, in bringing nations together and fostering exchanges between governments, society, and scientists, as well as in providing to the extended oceanographic community access to data, information, and science. From UN conventions to community-based meetings, we bring to the table authoritative, vital ocean data to inform policy decisions, to support the implementation of the Sustainable Development Goals, and ultimately to harmonize humanity's relationship with the planet. To face a climate crisis of planetary scale, we are bringing together the world's leading expertise, decision makers, action-driven innovators, and engaged citizens around the UN Decade of Ocean Science for Sustainable Development. Join us to co-design and co-deliver transformative ocean science solutions to create the ocean we want. You too can be part of the ocean knowledge revolution.
This is the news at 7 p.m. The new climate report from the UN says that cuts in enough to reduce greenhouse gases. A radical change is needed in how food is produced. That is to say, fewer calories.
We're always told we need to stop. Stop driving. Stop flying. Stop using plastic bags. Stop eating meat. Stop ignoring the science. But science also tells us that just stopping won't be enough on its own. If we're going to save our future, we also need to start. Start thinking outside the box. Start managing marine resources more productively. Start developing more climate-friendly technology for waterborne transport. With innovation, we can rid the oceans of microplastics. The forces of nature are fundamentally sustainable. We must make the most of it. The world needs more ideas. Solutions not yet thought of. This is not the time to stop. Especially now, when we're just getting started.
The ocean has always been a part of us Norwegians. It has provided us with wealth and prosperity, fisheries, shipping, offshore oil and gas. Now we're on the brink of a new digital age, facing global challenges to sustainability, where the jobs we create must support a green future. The solutions to many of our challenges lie in the oceans. But in light of these new challenges, we must learn to adapt in step with change. Ocean Space Center is the key to our ocean-based industries of tomorrow, a cross-disciplinary center for both established and new industries that will bridge the gap between resource and knowledge economy, connect and develop all disciplines within the maritime industries. In Ocean Space Center, simulations and model experiments will run in parallel to prevent accidents and damage to the environment. This is where industry and researchers will develop new concepts for renewable and cleaner energy production, as well as efficient energy consumption. At Ocean Space Center, future maritime transport systems will be created and tested, like autonomous systems that open up new markets for shipping and advanced technologies. This is where our knowledge and experience about materials and maritime constructions put us in the forefront of developing solutions for emerging industries. At Ocean Space Center, Norway's technological advantage will provide the key to sustainable aquaculture concepts and harvesting of species further down the food chain. This is where we develop research and technology that will clean up the oceans and protect our ecosystems while there is still time. Maybe the next great medical breakthrough comes from an organism living in our oceans. Ocean Space Center is both ambitious and essential. World-leading physical laboratories and digital tools, combined with excellent research, will help tomorrow's solutions become reality. The next generation of research scientists and ocean space technologists will retain and strengthen Norwegian competitiveness and develop a sustainable global ocean industry. The ocean has always been a part of us Norwegians. Ocean Space Center will keep us connected in the future.
The 16th World Ocean Forum will be held as a hybrid forum in Busan, the capital of Northeast Asia. Time to listen to the world's renowned marine environment experts to make ocean as uniters. You can participate in the forum in person or online to listen to professional sessions and various events for sustainable development and check the trends of the global maritime industries faster than anyone else. We invite you to the 16th World Ocean Forum to be held in Lotte Hotel Busan for 3 days from October 25th to the 27th.
Busan, Korea is already reaching the entire world, like ocean waves that travel far and wide. It's Busan, the perfect World Expo city, transforming our world, navigating toward a better future.
The ocean is a major source of life, food and livelihoods for 3 billion people across the planet. For over 60 years, UNESCO's Intergovernmental Oceanographic Commission has been working at the heart of the United Nations to generate the knowledge we need to conserve and manage this global marine ecosystem. We coordinate sciences, observations, data, and tsunami warning systems. We deliver knowledge, scientific understanding, and capacities to ensure the ocean is managed sustainably and equitably for the benefit of humanity and the planet alike. As ocean pollution, acidification, and warming grow, IOC's role has become crucial as the UN platform to discuss the increasingly relevant issue of ocean health and climate change, in bringing nations together and fostering exchanges between governments, society and scientists, as well as in providing to the extended oceanographic community access to data, information and science. From UN conventions to community-based meetings, we bring to the table authoritative, vital ocean data to inform policy decisions, to support the implementation of the Sustainable Development Goals, and ultimately to harmonize humanity's relationship with the planet. To face a climate crisis of planetary scale, we are bringing together the world's leading expertise, decision makers, action-driven innovators, and engaged citizens around the UN Decade of Ocean Science for Sustainable Development. Join us to co-design and co-deliver transformative ocean science solutions to create the ocean we want. You too can be part of the ocean knowledge revolution.
This is the news at 7 p.m. The new climate report from the UN says that cuts in enough to reduce greenhouse gases. A radical change is needed in how food is produced. That is to say, fewer cans.
We're always told we need to stop. Stop driving. Stop flying. Stop using plastic bags. Stop eating meat. Stop ignoring the science. But science also tells us that just stopping won't be enough on its own. If we're going to save our future, we also need to start. Start thinking outside the box. Start managing marine resources more productively. Start developing more climate-friendly technology for waterborne transport. With innovation, we can rid the oceans of microplastics. The forces of nature are fundamentally sustainable. We must make the most of it. The world needs more ideas. Solutions not yet thought of. This is not the time to stop. Especially now, when we're just getting started.
The ocean has always been a part of us Norwegians. It has provided us with wealth and prosperity, fisheries, shipping, offshore oil and gas. Now we're on the brink of a new digital age, facing global challenges to sustainability, where the jobs we create must support a green future. The solutions to many of our challenges lie in the oceans. But in light of these new challenges, we must learn to adapt in step with change. Ocean Space Center is the key to our ocean-based industries of tomorrow, a cross-disciplinary center for both established and new industries that will bridge the gap between resource and knowledge economy, connect and develop all disciplines within the maritime industries. In Ocean Space Center, simulations and model experiments will run in parallel to prevent accidents and damage to the environment. This is where industry and researchers will develop new concepts for renewable and cleaner energy production, as well as efficient energy consumption. At Ocean Space Center, future maritime transport systems will be created and tested, like autonomous systems that open up new markets for shipping and advanced technologies. This is where our knowledge and experience about materials and maritime constructions put us in the forefront of developing solutions for emerging industries. At Ocean Space Center, Norway's technological advantage will provide the key to sustainable aquaculture concepts and harvesting of species further down the food chain. This is where we develop research and technology that will clean up the oceans and protect our ecosystems while there is still time. Maybe the next great medical breakthrough comes from an organism living in our oceans. Ocean Space Center is both ambitious and essential. World-leading physical laboratories and digital tools, combined with excellent research, will help tomorrow's solutions become reality. The next generation of research scientists and ocean space technologists will retain and strengthen Norwegian competitiveness and develop a sustainable global ocean industry. The ocean has always been a part of us Norwegians. Ocean Space Center will keep us connected in the future.
저한테 와주시면은 이거 PDP 뜨는 거 보여드리겠습니다.
The 16th World Ocean Forum will be held as a hybrid forum in Busan, the capital of Northeast Asia. Time to listen to the world's renowned marine environment experts to make ocean as uniters. You can participate in the forum in person or online to listen to professional sessions and various events for sustainable development and check the trends of the global maritime industries faster than anyone else. We invite you to the 16th World Ocean Forum to be held in Lotte Hotel Busan for 3 days from October 25th to the 27th.
Busan, Korea is already reaching the entire world, like ocean waves that travel far and wide. It's Busan, the perfect World Expo city, transforming our world, navigating toward a better future.
The ocean is a major source of life, food and livelihoods for 3 billion people across the planet. For over 60 years, UNESCO's Intergovernmental Oceanographic Commission has been working at the heart of the United Nations to generate the knowledge we need to conserve and manage this global marine ecosystem. We coordinate sciences, observations, data, and tsunami warning systems. We deliver knowledge, scientific understanding, and capacities to ensure the ocean is managed sustainably and equitably for the benefit of humanity and the planet alike. As ocean pollution, acidification, and warming grow, IOC's role has become crucial as the UN platform to discuss the increasingly relevant issue of ocean health and climate change, in bringing nations together and fostering exchanges between governments, society, and scientists, as well as in providing to the extended oceanographic community access to data, information, and science. From UN conventions to community-based meetings, we bring to the table authoritative, vital ocean data to inform policy decisions, to support the implementation of the Sustainable Development Goals, and ultimately to harmonize humanity's relationship with the planet. To face a climate crisis of planetary scale, we are bringing together the world's leading expertise, decision makers, action-driven innovators, and engaged citizens around the UN Decade of Ocean Science for Sustainable Development. Join us to co-design and co-deliver transformative ocean science solutions to create the ocean we want. You too can be part of the ocean knowledge revolution.
This is the news at 7 p.m. The new climate report from the UN says that cuts in enough to reduce greenhouse gases. A radical change is needed in how food is produced. That is to say, fewer calories.
We're always told we need to stop. Stop driving. Stop flying. Stop using plastic bags. Stop eating meat. Stop ignoring the science. But science also tells us that just stopping won't be enough on its own. If we're going to save our future, we also need to start. Start thinking outside the box. Start managing marine resources more productively. Start developing more climate-friendly technology for waterborne transport. With innovation, we can rid the oceans of microplastics. The forces of nature are fundamentally sustainable. We must make the most of it. The world needs more ideas. Solutions not yet thought of. This is not the time to stop. Especially now, when we're just getting started.
The ocean has always been a part of us Norwegians. It has provided us with wealth and prosperity, fisheries, shipping, offshore oil and gas. Now we're on the brink of a new digital age, facing global challenges to sustainability, where the jobs we create must support a green future. The solutions to many of our challenges lie in the oceans. But in light of these new challenges, we must learn to adapt in step with change. Ocean Space Center is the key to our ocean-based industries of tomorrow, a cross-disciplinary center for both established and new industries that will bridge the gap between resource and knowledge economy, connect and develop all disciplines within the maritime industries. In Ocean Space Center, simulations and model experiments will run in parallel to prevent accidents and damage to the environment. This is where industry and researchers will develop new concepts for renewable and cleaner energy production, as well as efficient energy consumption. At Ocean Space Center, future maritime transport systems will be created and tested, like autonomous systems that open up new markets for shipping and advanced technologies. This is where our knowledge and experience about materials and maritime constructions put us in the forefront of developing solutions for emerging industries. At Ocean Space Center, Norway's technological advantage will provide the key to sustainable aquaculture concepts and harvesting of species further down the food chain. This is where we develop research and technology that will clean up the oceans and protect our ecosystems while there is still time. Maybe the next great medical breakthrough comes from an organism living in our oceans. Ocean Space Center is both ambitious and essential. World-leading physical laboratories and digital tools, combined with excellent research, will help tomorrow's solutions become reality. The next generation of research scientists and ocean space technologists will retain and strengthen Norwegian competitiveness and develop a sustainable global ocean industry. The ocean has always been a part of us Norwegians. Ocean Space Center will keep us connected in the future.
네, 안녕하십니까. 곧 이어
Good afternoon. We will begin track 2, digital transformation, shortly. Please take your seats.
Soon begin track 2, digital transformation session. So please come inside and take a seat. 네, 그리고 통역 안내해 드리도록 하겠습니다. 본 포럼은 한국어와 영어로 동시 통역을 제공하고 있습니다. 통역이 필요하신 분들께서는 테이블 위에 놓인 수신기 사용하시면 되고요. 한국어는 채널 1번 그리고 영어는 2번으로 맞춰주시면 되겠습니다. And we provide simultaneous interpretation into Korean and English. If you need interpretation, please use the receivers on the table and please turn to channel 1 for Korean and 2 for English. 그러면 잠시 후에 저희 본격적으로 시작하도록 하겠습니다. 감사합니다. 네, 안녕하십니까?
Good afternoon, ladies and gentlemen. Did you enjoy your lunch? I did. In the morning, we had a decarbonization session. And also in the afternoon, we have a very interesting session. This afternoon section is going to look at digital transformation, or DET in short. With the outbreak of COVID-19, DET has become a big issue, and the ocean industry is no exception when it comes to how DET, thinking about how DET can be applied. Before we begin, I'd like to invite our chair, President An Kwang-hon, CEO An Kwang-hon of Hyundai Heavy Industries. Please welcome him with a big round of applause. Good afternoon. As introduced, I'm An Kwang-hon. Did you enjoy your meal? Let me quickly introduce myself. As you may well know, I'm a very hot guy. I spent 300 days overseas, and I also represent Hyundai Heavy Industries along with Korea Shipbuilding and Ocean Engineering. And regarding shipbuilding, ocean development, and business projects, and also digital transformation, decarbonization, which are hot topics. Well, I am one of the leading persons in terms of trying to introduce such technologies and such concepts. In the morning, Professor Lee chaired the session for decarbonization, and we looked at new technologies and global markets. And in the afternoon, the session that I'm going to chair is on the basis of decarbonization. We are going to switch gears to look at DET. And the theme of track 2 is digital transformation, a new era of digitalization for ocean industry. What we need to think about is, well, people keep talking about decarbonization. Then why DET when decarbonization is such a hot topic? For Korea in 2008 and in 2009, well, we saw the highest volume for orders for vessels and ships. In 2008, it was diesel vessels. And at that time, we didn't have much talk around climate change or environment. But now we have a completely different environment with different climate. So decarbonization that we talked about 2 to 3 years ago differs from what we're talking about now. So in a very short period of time, we are seeing drastic changes. As you may well know, when we have new types of fuels, and why don't we adopt technologies from other industries, and why do we have to take actions quickly? You're asking such questions. And global financial crisis, supply chain crisis, decarbonization, these are the major issues. And there are orders for the largest ships, and 60 to 70% of orders are from Korea, and we have all these new fancy technologies. But why do we keep talking about crisis? That is something we're going to delve into today. And after the era of the pandemic, going forward, our future generation might be faced with more threatening virus than the coronavirus. And in this case, how can we be prepared for this new paradigm and who will be the major players in this era. So when it comes to shipbuilding and marine transport, we're going to look at digital trends in this field. And the trend of DT is about changing their business models to transform their businesses, to set new directions for the industry. In the field of the ocean industry, in shipbuilding and transportation, we can preempt the market on the basis of DT. And in order to be net zero, we need to secure DT first. So regarding this topic, that's the perspective that we're going to take today. Then let us move on to the session and welcome our first presenter. The first presenter is CEO Im Do-hyung of Avicus. The title of his presentation is Commercialization Status of Low-Level Autonomous Ship Solution. CEO Im Do-hyung worked for the Korean shipbuilding and ocean engineering for a long time, and he is the renowned expert in this field. And from 2021, he started this spin-off startup of Hyundai Heavy Industries, and he is the CEO of Avicus. He participated in the CES 2022 and demonstrated the technology that enables full autonomous navigation and announced the technology version 1.1, 1.0, and 2.0. And also, he made a successful voyage across the Pacific. In the era of digitalization, he's going to talk about this autonomous solution. Please welcome him with a big hand.
네, 안녕하십니까?
Good afternoon. CEO Im Do-hyung couldn't make it today because he had another business to attend to. My name is Kim Do-hyuk, and let me talk on behalf of him. Let me start the presentation. So the name of the company is Avicus. It's a spin-off company of Hyundai Heavy Industries. And from 2021, it had a whole new start. And we call my company a startup of HHI. And it is developing autonomous solutions for ships and vessels. Safety, convenience, and profits for customers. These are our focuses, and we want to change the paradigm of the shipping industry. Before Hyundai Heavy Industries had spin-off companies like Avicus, it was focused on developing autonomous technologies. And we started back in 2017 to develop various solutions, and 2019 we had some commercialized solutions, and in 2021 with all these technologies we started our company. So automation, autonomous technology, these are the things that we put our focus on, and we want to change the targets of our autonomous navigation. And among these topics, my presentation will be focused on how these technologies are being utilized in the industry. Before we talk about the technologies, first I'm going to touch upon the concept of autonomous vessels. IMO, a few years ago, had 4 different levels in terms of its autonomous levels, and the definition of classification of the levels can be straightforward, but at the same time it can be very vague because it's not always easy to draw a clear line, and many things have to be automated. So we see many companies, consortia, and at a country level, we see that many different players have different classification of autonomous levels. But what we at Avicus is focused on is we want to focus on assisting humans. So we have the issue of insurance policies and responsibility issue. So ultimately, we are going to see fully autonomous technologies, but even though we follow this direction, we want to take a more step-by-step approach. When it comes to core technologies or key technologies, there are different steps. First, it starts with detection, sensing. So it's like eyes, human eyes. And second, situation analysis. So by having data received from eyes, we understand the situation. The third stage is planning. To put it differently, it can be understood as decision. On the basis of information and data, you decide how you're going to act. So up until this point, this is about monitoring and assisting the humans. And the actual control, which is the fourth stage, replaces navigation and actual operation. So we have to complete the 4 stages so that we can be fully autonomous. In the big commercial ships and also in leisure boat solutions, Avicus is covering both of the areas. And even though technologies can be slightly different, the core technologies are basically the same. And the proven technology can be transferred to other types of vessels. That's why we entered the leisure boat business section. HINAS was developed for big commercial ships, and that stands for Navigation Assistance System. And in the middle, you can see HIBAS. And also, HINAS 2.0 includes control. HINAS is navigation assistant. So a bridge and crew members' activities are assisted using HINAS. Cameras and detected data, we're using this information to understand what kind of risks we have, and the information is assisted. And this image shows what the user sees. So it's only seen through a bridge, but in a captain's cabin. And in land, we want to be able to see this image. So that's what we are working on. But when it comes to the actual levels, well, there can be some limitations. But if we can achieve this, I believe that we can reduce the number of crew members. And going forward, we believe that we can move towards fully autonomous. Second, HIBAS, the general navigation information, and also the movement at the keel. Well, these 2 cases are very different, and the speed of vessels will be different, and different tug vessels will be used. So we need an intuitive image as a result. So this looks like an around view for vehicles, but unlike views for automotive vehicles. We use more cameras with more cables to show unique images for ships only. And this can be used for container ships, CPC. And this technology is quite popular with these vessels. So based on retrofitting the vessels, this technology is introduced to such users. And this HINAS 2.0 includes the concept of control. So instead of just getting support from the system, this is about giving control. And instead of replacing what we have, what we want to achieve is the software or the algorithm of our software is connected to the existing systems to control. So it's not replacing equipment, but it's to replace the judgment of a captain or a crew member. Well, at the moment, the level of development is not really replacing their judgment, but currently we are able to provide assistance for them. And if it's a month-long navigation, then we can first start with 1 week or 2 weeks of assistance so that we can expand that assistance. Not just for big commercial ships, but for small leisure boats, we can use this technology. And we are developing technologies for these leisure boats. So actually, the technology can be sometimes simpler, but it can be risky from time to time because it is light in weight and it is less stable. So we are diversifying the types so that we can adjust the technologies. So first, starting with small vessels, we can expand to include more larger vessels, including ferries and so on. And the core technologies for large commercial ships can be applied to small leisure boats as well. And in developing these technologies, we also have to prove that these technologies work. So we do the tests, which takes a lot of time. And in order to communicate with our subcontractors and customers, we have this major event. In 2022, in June, we retrofitted a small vessel. And this is the actually unmanned cruise that we did in Pohang area. And we learned lots of things from this voyage. And on the right-hand side, like the LiDAR, ARS, we use lots of sensors to control this boat. And also, we made a trans-Pacific voyage from Houston to Busan, Korea. And 4 researchers are on board. And for 1-month voyage, well, for the first week, we had a technical interview with captains and crew members, and we had tests during that time. And in the later part, for 2 weeks, there was no intervention, and the navigation was done autonomously. And regarding the weather conditions and communications with the land and the status of cargoes, all this general information was collected. And that was a very good lessons learned. And we believe that we learned more things than what we can learn from sales. So 350 hours for 10,000 kilometers and 100 encounters, where the actual figure is much higher. But anyway, we saw that the ship stuck to its route and sometimes it made avoidance. And also, we wanted to make sure that how fuels can be reduced. And we wanted to learn what would be the optimum RPM for fuel efficiency. And we tried the recommended RPM at the request of a captain. And we saw the possibility of connecting optimal navigation with autonomous navigation. So our strategy that started with 2019 was in full bloom in 2021. And now we are putting these technologies into vessels, but we need to make sure that stability and reliability of these technologies are guaranteed, and we're working with classification societies. And for navigation assistance, we do not have performance criteria, so it has to be done for each case, and we're working with MOF and the Korean register to work on these approvals and certification. Hyundai Heavy Industries takes an order for more than 100 vessels every year. And we build new ships, and also there are commercial ships that are being built in China. And also delivery is done to other domestic shipyards. And on the basis of this data, I believe that we can have more track record using these technologies. And the thing that I didn't want to miss out on was, well, many consortia and many other partners are working on this in the UK and in Europe on the basis of these technologies. And even if they do not have such technologies yet, they are working on the standardization documents. If we can collaborate more closely regarding the future technologies that we're going to utilize, I believe that Korea can lead the technologies, but not just a technology leader, but we can also be a leader in regulations and certification. And in that regard, I believe that we can work even closely with relevant parties in this field. So that is the end of my presentation. Thank you. Let me thank once again Mr. Kim Do-hyuk, Dr. Kim Do-hyuk, for your great presentation, which was done on behalf of CEO Kim Do-hyuk. Please give him a big hand for his great presentation. As Dr. Kim mentioned, autonomous ships were there a few years ago, but when it comes to standards, international standards and regulations are not fully developed. We're working on them, but in global markets, we believe we will see standards and regulations for autonomous ships. And for many new ships, these are being applied.
And the second presentation this afternoon will be by on the maritime digital transformation through international cooperation in IMOFAL. We have Dr. Arnold Jan Rosef, senior scientist at Sintef Ocean. Arnold Jan Rosef, the senior scientist, has come all the way from Norway to be a part of the World Ocean Forum. For the past 25 years, Mr. Rosef has been a well-known researcher in maritime information and communication technology. and he is the world's best expert in the development of relevant ocean standards. Please welcome him with a big hand.
Thank you for the introduction. Many of you, or some of you, have met me in conjunction with autonomous ships, but today the theme is more digitalization in general. The first question is perhaps already answered in the first session today. We are looking at big challenges in terms of decarbonization of shipping. One of them is zero carbon fuels. We are looking at prices of fuel which can be from 3 to 6 times higher than heavy fuel. The volumes are bigger, they are dangerous, they are corrosive, so on and so forth. And you can argue that this will require new types of shipping systems, new types of ships, and possibly new business models, and certainly a digital transformation. One example we have from Norway, this was, at least last year, the world's biggest plant for production of liquid biogas, with a capacity of about 25 tons a day. It's a fairly big plant, and it uses raw materials from the paper industry and from the aquaculture. However, if you look at the energy demands for one of these large container ships, they will need about 150 tons LNG per day. So you need 6 of those plants for one ship. So I think it's quite obvious that we have to look also for more energy efficient systems, better systems, newer types of transport systems, in addition to all the work that needs to be done on alternative fuels and alternative machinery. Also, we had the Ever Given incident some years ago with a huge queue of ships in the Red Sea as a result of big disruptions in international trade. And we also have gone through the COVID epidemic with stops in LA, delays also in many types of shipping, crew that cannot come off the ships, so on and so forth. Digitalization will not solve this problem, but it's an important component in partly avoiding them and also to fix the problem when it occurs. And how do we do this? A lot of people are talking about digital transformation. I'm not sure if we can, for instance, use the principles they use in the mobile telephone industry, but we'll come back to that. If you look at digitalization or the digital transformation, you could look at it as a kind of 3-step procedure. At the bottom, you have to do a digital transformation. You have to convert all your paper to a digital format. This will not save you money, it will cost you money. It will save some paper, it will save some storage, but basically this is a costly process. Again, standards will help you to do this cheaply because it can show you how to do this and you get some previous experience. The next step, when you have digitalized, when you have made your stuff digital, then you can do digitalization, which is basically automating the processes, mostly in-house, but also between companies. To do it between companies, you need standards. To do it in-house, standards will help you to save money. But the interesting thing with standards is that they enable the digital transformation. If you have a standardized way of transferring information between parties, you have standardized information models, stuff like that, it becomes much easier to make new types of applications, to save fuel, to avoid disruptions, and so on. And this is here the money can be earned. And also here, the new business models will be created. So standards create an ecosystem, in a sense, which enables the digital transformation. And my point of view is that we cannot have a digital transformation of the shipping industry without standards. As I mentioned, if you look at the mobile telephone industry, it's a fantastic rate of innovation there. But the basic for that is that we have around 7.5 billion smartphones, even more, in the world today. Not all of them used, but all of these phones are on two platforms, most of them anyway. So if you make a new smart application, you have a big market to sell it to. This is not the case in shipping. Depending on how you count, we have between 50 and 120,000 ships in international trade. If you count those bigger than 100 gross tons, it's 96,000 1 year ago at least. And all of these ships are different. You have to do a lot of commissioning to take one software, say an energy optimization system, from one ship to another. Even if they are sister ships, they are typically built with 1 or 2 years in between. And that creates differences in the IT system. And again, we have to avoid this and try to get standards in place that kind of builds over this variance in platforms. The second point, which we are trying to also emphasize, is that shipping is international. The ships, they move between ports all over the world. And we need standards that are international. It won't help a ship if a digital communication with a port in, say, Busan is very different from the same type of communication in Singapore or Rotterdam. We have to have the same protocols. And one of the problems we have today is a number of different initiatives covering more or less the same application area. Here are some examples from a very relevant example, the Maritime Single Window. The new FAL Convention requires that every signatory implements an electronic Maritime Single Window January 1st, 2024. And here we have some different standards to select between, and there are more. This is not necessarily a problem, and it may even be necessary if you look at the local, regional system. Then you can allow to have the regional, local standards. But again, for ships moving between ports all over the world, we really need to have standards for things like that. And according to Lloyd's, it's about 8,000 international ports in the world, so you can imagine what kind of problem we have if everybody has their own standard or specification. So again, international cooperation is needed, and we need to do it through robust and recognized standard organizations. And it's here that IMO actually has taken some action to solve this problem. The Facilitation Committee, which is not so often heard about, they have established an expert group on data harmonization, which have developed what they call the IMO Compendium, which is a reference model for exchange of information between ships and shore, mainly focusing on the Maritime Single Window so far, but also increasing into other domains. How does this work? It started as a cooperation between IMO, UNECE, which is responsible for the EDIFACT standards, World Customs Organization, and ISO. And you could roughly say that World Customs Organization is responsible for the governmental data exchanges. UNECE is mostly into trade, while ISO is working on operational data exchanges in the shipping domain. And the overlap between these standards in the area of Maritime Single Window was kind of determined through the analysis of the FAL Convention, and we agreed on developing a common reference model that could be mapped to each of these standards. And that means that you can select between EDIFACT or ISO XML standards when you implement your Maritime Single Window, but there is semantic interoperability between information elements. And this is basically the IMO Compendium. This has been updated as the years have passed, and we are now into a cooperation between several relatively big organizations, BIMCO among them, International Association of Ports and Harbour, IHO, GS1, DCSA, and so on and so forth, trying to extend the data model also into other types of communication between port and ship. And we are currently working on just-in-time arrival for the ships. And this means that you can implement just-in-time arrival with standardized protocols in every port that implements the international standard. And the point here is that the IMO compendium is not the standard in itself, it's a reference. So if you implement this in IHO models, for instance in terms of bollard IDs and overlays on the ECDIS, these data elements will be compatible with voyage orders to the captain, including berth positions and stuff like that. So it's a reference model that can be mapped to individual standards for different domains. So this is a very interesting development that has increased interest in standardization tremendously in the shipping sector. And I would really encourage you to have a very close look at this work, particularly if you work with digital standardization, and try to get into this working group so that also new standards, new protocols are at least enabled to be compatible with existing standards. Another point which is very important is digital trust. When you digitalize working processes, for instance, just-in-time arrival, in principle it means that you remove the human from the loop. And that also means that you remove the human sanity check from the loop. And the computers will be very reliant on authentication and integrity checks of the data. You need to have digital signatures on these information exchanges. This applies to stuff like autonomous systems, which will be totally without crew, but also for traditional shipping that are becoming more and more dependent on digital information exchanges. And this has to be internationally accepted. IMO has already provided a guideline for this based on private-public key system, which defines how this could be done. And we are considering whether we should set up an international, what we call a public key infrastructure, for instance through IMO, to provide a kind of international accepted digital certificates for this type of information exchange. And that could even be handled in the FAL Convention to make it easy to incorporate in national law that this type of signature could be accepted. Myself, I'm active in ISO, and we are working on the ISO version of the Maritime Single Window Standards, the 28005 electronic port clearance, where we are currently developing Part 1, Payload Agnostic Transmission Protocol. And we are also developing Part 3 now for just-in-time arrival and various other types of information exchanges in the maritime sector. So to sum up, a digital transformation is needed. I think that was also underlined in the first session today, that we really need digitalization in addition to all this hardware and new types of fuels to sustain sustainable development goals, particularly for decarbonization, but also for increased resilience and other parts of the sustainable development goals. And my statement is that a digital transformation will require international standards. I don't think the shipping sector is big enough. 100,000 ships is nothing compared to 6 billion mobile phones. We really need to cooperate, and we really need to work through international standards to get this digital transformation working. And obviously, international standards will also require international cooperation and coordination. It's a very small sector, the shipping sector, and we cannot afford that everybody is developing their own specification and standards. We really need to coordinate and cooperate on this. When I go to conferences, it's the same faces I see each time. It's a very small sector. Digital signatures is also something we will need, so that has to be considered, and again, internationally agreed on and standardized. And I also encourage you to have a look at the development of the ISO 28005 series to see if that's something you can use. So that was what I was planning to say. Thank you for your attention.
Thank you this morning and again this afternoon. We are now discussing digital transformation. As Dr. Jan Rosef has mentioned, currently under development and the future leading shipping, marine transport, digital transformation efforts. What's most important is to have trust and international cooperation in the process. And although much efforts are being made for development, each party has their own technologies to develop their own standards. This is not enough to cover the large population and different sectors. And so international standards, cooperation and coordination are absolutely important in this process. In different schools and organizations, I'm sure you're preparing for this. And so I hope that as soon as possible, the ISO 28005 comes to a completion so that we can better prepare for the digital transformation that is really happening very quickly. Again, please give another big round of applause to Mr. Rosef.
Next, please welcome Senior Director Yeon Jong-hum of Port Research and Development Department of Busan Port Authority, or BPA. The topic of his presentation is Smart and 5G-based Busan Port Digital Twin Platform. Dr. Yeon Jong-hum at BPA is responsible for developing new technologies and state-led R&D projects. Please welcome him with a big round of applause.
네, 반갑습니다. 방금
Good afternoon. I'm Yeon Jong-hun, and I'm the head of the R&D department of BPA. Today, I'm going to talk about smart and 5G-based Busan Port Digital Twin Platform. And this is a table of contents, current situation, concept of digital twin platform of Busan, followed by future goals and plans. First, current status. Well, Mr. Jin-gyo already had a presentation this morning, so let me be brief. Well, we were placed on the 3rd place, and as of 2021, we're the 7th largest container terminal, and in terms of transshipment, we're the 2nd largest. And the throughput is 22 million a year. And we believe that the figure is going to increase to 32 million TEU by 2030. And in accordance with increasing throughput, we are developing the Busan ports, and we're going to build port infrastructure which will enable 54 very large container ships by 2030 at the same time. And next is about how we are operating the port. So from manned, it moved to mechanization to unmanned automation. So between equipment and between people, we sometimes fail to communicate, and that led to safety accidents. So the picture that you see is that there is a vessel 3 years ago that was entering the port speeding, and there was a crash as a result. And in the middle, in the vessels, or with with trucks, you can see that these vehicles collided. And on the far right, the average area of the terminal is 800,000 square meters. It's a very large area, and it's very difficult to monitor this large area in real time. The second challenge is that it's very difficult to optimize the operations of the terminal. Of course, we have the pre-work plan using the terminal operation system, or TOS. But on site, we have many variables, and we fail to stick to the original plans, and also there can be changes of information, and there can be late arrivals of trucks and vehicles, and also there can be accidents. And in this case, all these variables lead to unexpected outcomes. The last challenge is in the gate area and in the hinterland area, there is heavy traffic congestion. The productivity of a port is about how many containers are handled by cranes. But in reality, it's really about how vehicles and vessels arrive on time, and then they have to leave on time so that it doesn't lead to any bottleneck. And we were not always efficient when it comes to this bottleneck or dealing with these issues. And due to the corona pandemic, the volume of container cargoes increased drastically. So this has become an important issue. In order to resolve this, we need to share information and have effective communication. So regarding the lack of information and differences of schedule, we thought that developing digital twin platform can be effective. What that means is that we can build the exact same environment in a virtual environment. And using this digital twin, we can do the data linkage, modeling, and search past data. And using fine-tuned simulations, we can make better predictions, accurate predictions, and make forecasts for the future as well. And also, it enables unmanned autonomous operations. I mentioned various challenges in the port of Busan, and we thought that digital twin can be the best solution to solve all these issues. In overseas markets, there are various attempts using digital twin technologies. For instance, in the port of Rotterdam, it announced a plan for 2019 digital twin technology and installing IoT sensors and securing safety of workers and vessel traffic management. It is closely working with IBM. And also, in the port of Singapore, it is keen on developing the smart shipping, and it's currently building the Tuas port. And in Germany, in the port of Hamburg, it's trying hard to resolve the traffic congestion using smart road systems. And using the IoT sensors, the sensors can identify where the bottlenecks are created, and it can change traffic signals based on the outcomes. And the last one is the case of a Finnish port, Oulu. So it's about dealing with the safety of entry and departure of vessels. And cranes, vehicles, these are being monitored using the digital twin. So they were the 4 examples of overseas ports. And next I'm going to talk about how these digital platforms can be used to connect the hinterland logistics functions. And even though we haven't developed this concept in a full manner, I believe that for a particular or specific terminal, we were the first case to develop such a digital twin platform. We carried out a demonstration project, and that was for this particular terminal, Busan New International Terminal, PNIT. This was organized by the BPA, and that was about increasing the productivity linkage of the hinterland and improving integrated platforms. And that was supported by the Ministry of Science and the Busan Metropolitan City using public and private funds. And also, it got support from the Ministry of Fisheries in an administrative efforts. And this is about data linkage and optimization of scheduling between three different elements: ships, ports, and hinterlands. And regarding ports and vehicles and the GIS data, operation schedules are integrated to come up with optimal navigation data and optimal navigation route. And receiving the real-time TOS information, control can be given, and also simulation modeling and virtual terminal can be realized. And this is how the Busan Port Digital Twin Platform hardware looks like. So from the digital twin server, you can see all the necessary information that's presented and analyzed in real time. And also this one shows how the hardware looks. In line with the government communication policies, it's based on 5G, and it can receive data for location in high precision and high speed. And the digital twin server is located in the server room of the PNIT, and the data is being utilized by the control center. And this is the actual image, as you can see from the left bottom end. This shows the actual entry and exits of the Busan port in real time, and the red line shows the optimal entry route, and the yellow shows the exit route. And on the top left, it is the navigation route, and this information is given to shipping companies and vessels. And the second image shows the general statistical information that is shown on the integrated dashboard. So if you do the comparison of the effects of the digital twin platform, predictability used to be 75%, and that increased to 92%. Data consistency increased to 95%. And by resolving traffic congestion, fuel consumption improved by 30%. This data utilized and reflected the full-scale ship data that was built by DSME and operated by HMM. And on the second slide, this is about the productivity increase. And on the top right, you can see the location information and TOS information that is shown in real time. And you can do the monitoring of this data. I told you that the area is about 250,000 pyong. So it's rather big to do the monitoring accurately. And if you put the cursor on the part that you want to see, then you can check the information that you'd like to see. And also the yard container information is also presented. And by clicking on this image, you can tell which shipping company, who's the owner, and what cargoes are being moved. And on the bottom, this is the virtual terminal that was realized. And the loading and unloading outcomes can be tracked back using simulations, and also we can optimize the activity. And also you can adjust the volume of cargoes. And also the schedule can be adjusted depending on whether the vehicles or vessels arrive on time or are delayed. And with the introduction of the digital twin platform, this is the effect that we analyzed. So when it comes to the throughput, it was very difficult to predict the throughput, but now we can do it with the digital twin platform. And the optimization based on schedule led to productivity increase of 16.7%. And in the yard tractor, in the past, it was not GIS-based, but currently, now we can use the GIS information, and it's optimized to increase productivity by 15.4%. Next is about accuracy, how we increased accuracy and how it is connected to hinterland logistics. So the turnaround time and entry departure time, these are analyzed and monitored. And that led to the improvement of traffic congestions by 10%. And gate in and gate out time is reflected in turnaround time. If the turnaround time is very long, then that means more traffic and more congestion. So by reducing the turnaround time, you can actually reduce the load of the port. Next. Last is the integrated data platform. Virtualization is a good tool, but on the other hand, what we want to do is to do the integral analysis of data, and that's what we're providing exactly. Regarding vessels and cargo trucks, there is less time for them to wait, which leads to less CO2 and better air quality. Currently, this is not being deployed because we need at least 7 to 10 years data, but currently we only have the data for the past 5 years. So by accumulating more data, we believe that we can advance this function. Next one, future goal and plans. By 2027, we have this plan to have the digital twin platform to cover the Busan port as a whole, and that will lead to the reduction of 11 million ton CO2 reduction. And the operational cost will be reduced as well by 12 billion won. So our plan is to advance the platform operation plans, and starting from 2024, for the next 3 years, we will complete the digital twin platform development project. So you can refer to the rest of the slides for more information. And also we're working on the algorithms, and you can refer to the remainder of the information. So with that, I'd like to conclude my presentation on the digital twin platform. The Busan port, the port of Busan, will lead, and to become the leading port in the world, we'll do our best.
예, 세 번째로 발표해 주신 연정음 부산항공사
That was our third presenter. Thank you very much. So the biggest port of Busan and how it ranks the second in terms of transshipment, well, it was a very impressive presentation in terms of shipbuilding and shipping. For DT, we had lots of discussions, but in reality, when it comes to the vessels and systems that are mounted on these vessels, have to be transformed to be fully digitalized. In that case, this will affect the logistics platforms, logistics infrastructure, unless we secure cooperation between different systems. I don't think we can achieve digital transformation in its full scale. So in this respect, developing the predictability model and digital twin platforms will be meaningful and will be crucial. there were delays of transshipments in ports around the world, and that is a global risk many shipping companies share. So I believe that the Busan Port Authority can play a leading role, especially in the field of this digital technology. Thank you very much for the great presentation.
And moving on to the fourth presentation, we will invite Dr. Kim Jin, Principal Researcher of CRISO, to introduce the COS project. Dr. Kim leads the COS project, co-funded by the Ministry of Oceans and Fisheries and the Ministry of Trade, Industry and Energy. He is in charge of a number of autonomous ship projects. Going forward in the near future, autonomous ships will come to fore, and as we heard from the first presenter, Dr. Kim Do-hyuk, the autonomous ship is currently at level 2.0, but soon level 3.0 will be a reality, and also level 4.0. So once again, we will hear about the Korean technological development of autonomous ships. Let's hear it from Principal Researcher Mr. Kim Jin.
네, 안녕하십니까. 방금
Good afternoon. I belong to the CRISO, but right now I am in charge of the COS project, co-funded by the MOF and MOTI, and I am currently leading the COS project. Let me just briefly introduce to you the COS project, the Korean Autonomous Surface Ship project. And as you heard from the conclusion of Avica's presentation, let me show you how the technology can be verified. This is the order of my presentation. I will be mainly focusing on our validation process, what type of test infrastructure are being prepared, and the validation process that we are currently thinking of and what the scenarios are. And not only domestically, but internationally, validation will be an issue. So let me summarize with that. This project started in 2020. We are now in the third year of the project, and in 2025, the project will come to an end. MOTI, MOF are co-funding the project, and there is also a matching fund from the private sector. Busan City, Metropolitan City, is also a part of building the testbed infrastructure. A total of 51 organizations are a part of the COS consortium. Universities, shipbuilding companies, shipping companies, any companies that are engaging in research and development of technology regarding ports and ships. And CRISO and other research institutes are together a part of consortium. And CRISO and KR, the Korean Register, are the main leaders taking charge of the project management. So there are 4 core technologies. Number 1 is autonomous navigation system. Number 2, autonomous engine system. And number 3 is building the testbed and verification techniques that will be used to validate the technologies. And finally, operation techniques and standardizations, how that relate to how the actual autonomous ships will be operated and how international standards can be developed, as you heard from Ornov. Well, we now have a 24-meter long vessel that was launched this year as a test ship, and next week in Ulsan, remote controlling and monitoring center for autonomous ships will be completed. The remote control center will be completed next week. And from 2024 to 2025, the final years of the project, Pan Ocean ordered 1,800 TEU container ship will be where we will be attaching the developed technologies and systems for real-world validation. Let me introduce to you the results so far, starting with the situational awareness system that we call ISAS, which involves cameras, radars, LiDAR systems, GPS, IMU, and AIS. Within the OS, we have already developed a system to be aware of the situation. And automation of engine room is also very important to back up the autonomous ship system. The engines may become electrified, but it's very important to first automate the engine because there are many different failures that we see in the engine room. So we place the engine room onshore and test out the failure mode by creating artificial failures to see how the failures are detected and predicted. And next week in Ulsan, like I said earlier, the Shore Control Center will be opening. And there are different technologies that can be tested here. Simulation-based tests can be conducted, and the 24-meter test ship, as I mentioned, and as shown on the slide at the right-hand side, is also ready. And this is the autonomous ship remote monitoring and controlling digital twin bridge to be installed in Ulsan right now. It is located in the CRISO base in Daejeon. Ultimately, this system will be installed in Ulsan. So, in the end, the existing vessels are led and driven by captains and masters who are highly educated from maritime universities and higher education institutions. But when we use autonomous ships, who are we going to trust to operate those ships? How are we to trust such AI captains? How do we test them? How do we score them? So those are the main questions we are looking into as of now. And so we need to do both sea trial-based validation and simulation-based validation. We need a set of process to validate this and also to evaluate the system. To conduct these tests, a number of autonomous ships will be developed in the future, and they will be handling data in different manners. And so we need to test the data interface first. And there are some where there's a high risk of collision. It is not easy to test out those situations with actual ships. So we need to use virtual ships or set up a virtual situation to test out the risks to avoid collision. And for very difficult situations as well, we can use the virtual system. So this is what we do with our simulation-based tests. And then there will be the sea trial tests. And ultimately, we will use a mixture of actual ships and virtual ships in a hybrid test, which is also being considered. And we have a number of different digital systems. So in what scenarios are we going to test out those systems? And we are currently writing out the scenarios first with a situation awareness system. The colored dots on the map indicate fixed targets such as buoys that the ship needs to avoid. So we test with the constant heading situation to see if the ships are aware of those targets, and also with the course changing scenarios to test the same. These are the scenarios being developed, and the green ship is the test ship. So we want to also see whether the ship is aware of moving targets and also a mixture of both moving and fixed targets. So these are the scenarios that we are currently writing. And we also need to test the actual collision avoidance algorithm, whether the algorithms are accurate. First with the single traffic, when the other ship is coming head-on or crossing or overtaking the test ship. So we are considering a number of different such scenarios. And we also need to test a multiple traffic ships scenario where there are a multiple number of ships that the test ship needs to avoid, and we need to see whether the collision avoidance system is working properly. But as you heard from Avicus and from Europe, there are a number of different autonomous ship systems that are being developed, and the collision avoidance is being well done. But what's the level of difficulty and complexity that's involved in when the test was done? This is unclear. And globally, how do we evaluate the AI captains of these ships? This question remains unanswered largely, so we need to work together globally. The technical experts need to look into this issue and propose some solutions. So the level of difficulty of the scenarios tested should be defined for the insurance companies and also for the ships to actually sail well offshore. So we need a set of standards. This scenario is the one that we have developed to be as complicated as possible. We have the four, as you can see in the blue route, we have four corners that the ship has to turn. And we have different traffics that come across the route. As the test ship turns each corner, it comes across a number of different situations, and in reality, it will come across thousands of different situations. So we want to test out how the ship is working and properly avoiding collision. And what's also nice about this scenario is that perhaps for not so much for ocean-going ships, but for most of the vessels, they adhere to the IMO collision coal reg, but not so much for fishing vessels. So those vessels that violate coal reg, we also need to test those situations where the test ship comes across vessels that are in violation of coal reg. So this seems like a computer-generated graphic, but this is actually what we tested out on sea, 2 meter with a 2-meter vessel. So we just added a few computer graphics for your understanding. So you can see that actual ships are in traffic, and the wire-framed vessels are the simulation-based virtual vessels. So we created a very complicated scenario, as you can see here. About 1,700 different encounters with other vessels have been created in this scenario. And the algorithms that have been developed so far, where there's no wave and this test was done in a waveless lake, but the 24-meter test ship will be testing out the same scenario, and then after that, 1,800 TEU grade container ship will ultimately be used for the final validation. So for now, different units of technologies are being developed as part of COST project, and what we also need to consider is that once autonomous ships are actually commercialized, how do we discuss all these matters globally? How do we evaluate the autonomous ships? And later, when the ship registers, give certifications, what type of certifications will be issued? So those are the questions we need to have in mind as we develop the technologies, and we need to make some solutions and propose solutions. We can't do this alone. We need to work with other nations. As for now, Lloyd's Register, ABS, DNV, and V, 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 and V They do have a very validation system for each of their own digital systems, but the problem with autonomous ships is how the digital systems all come together and get integrated, and what kind of issues will arise once that integration happens, and how do we evaluate the integrated system? No one has an answer or a proposal to that. So these are questions that remain unanswered, and the IMO has proposed the autonomous ship levels, just very simple 4 levels. But those 4 levels are not really sufficient to be the clear basis on issuing certifications in the future. So we need to break that down further into more specific levels. And as Dr. Kim from Avicus has mentioned earlier, we need a scenario procedures to evaluate the autonomous ships with simulations or actual sea trials. And to conduct these procedures, we need a testing infrastructure and procedure for evaluation that also need to be standardized globally. And through the COST project, from Korea's perspective, and also on combining the different exchange of ideas with other nations in the process of conducting COST, we will present appropriate scenarios and procedures. Thank you very much.
지금까지
Well, so far, Dr. Kim Jin has given us a great presentation. He is leading the COST project. Please give a warm hand to Dr. Kim. So we have heard 4 presentations on digital transformation. And what's most important, well, my car has the latest launched technology. It is a Genesis model. It's semi-cruise enabled. So when I have to drive a long distance, I put it on cruise mode. And nowadays, I'm not worried, and I can just fall asleep with my car driving on cruise mode. But what's more concerning is that I cannot check whether the car is going the right way. Sometimes collision, the risk of collision, and as Dr. Kim has mentioned, the operation environment, operation control, autonomous control, all needs to happen at the same time. And I'm not sure whether that is actually working properly. I don't have that level of trust, and I don't think that the procedures are really there yet, although automobiles are more advanced than ships on that front. So for ships, it is not easy to develop such technologies and standards because they operate on a very wide, vast ocean. But the technologies and challenges that we need to develop and overcome, and the scenarios, all have been covered by Dr. Kim. Thank you very much for that presentation.
Then we're going to move on to the last presentation of digital transformation. Please welcome Mr. Lee Hyun-sok, Head of Business Development of Amazon Web Services. And he's going to talk about cloud management strategy. In the process of DT, Amazon had a successful transition, and he's going to share with us some success stories. Please welcome him with a big round of applause.
네, 반갑습니다.
Good afternoon. As introduced, I am Lee Hyun-sok from Amazon Web Service. We call it AWS. And I'm the head of business development. Today, I'm going to talk about the cloud computing technology, and I'm going to talk about the success cases at home and abroad to show you the DT trend of AWS global customers. We looked at different cases of shipping and shipbuilding, so I would like to look at slightly different industry to share with you the trend. And also, I titled my presentation Cloud Management Strategy, because DT is not the responsibility of just CIO or CDO, but also CPO, CMO, CEO. These are all relevant parties when it comes to DT. So before I look at specific cases, first I'm going to talk about why cloud computing for DT. At Amazon, this is the definition that we have on DT. Any activity to create incremental value to management value chain leveraging digital data. So by digital data, we need some management of this digital data. And it's about how we can manage this in an economic and scalable way. And the cloud computing technology enables us to do that. And the second one, in the past when we said cloud computing, it was about storing data less expensively, but now it's AI machine, big data, AI VR. And we're talking about the fourth industrial revolution that is provided through DT. And why cloud computing? The third reason is in the case of AWS, which is responsible for cloud, we have thousands of features that we launch every year. So even though we don't think we are providing all the necessary elements of DT, we actually lay out this ground for third parties to provide solutions. And many of these are SaaS solutions, and we provide more than 12,000 products. And also, this can lead to DT solutions. So it's basically about having that ground. 2 to 3 years ago, cloud computing, I would say, was used to all the industries. And now I would say that DT based on cloud computing is taking place in every industry, in every corner of businesses. Due to time constraint, I'm not be able to go through all the cases, but I'd like to show you some great examples. First, in the field of marketing and CRM, I believe that you know this company, Korean company, Market Collie, which is a delivery company of fresh food. In 2015, its revenue was 50 billion, but it increased drastically to 1 trillion won. And with drastic increase in productivity, it means that it needs to be equipped with IT technologies. And this huge growth in a short period of time was enabled by IT technology. So the first growth strategy was to secure new households as customers. And Market Collie successfully secured many households in metropolitan areas, so their first strategy was successful. And the second strategy was increasing sales per household. For that, they have to personalize and customize their services. They should be able to provide good suggestions and make good recommendations for personalization. In the past, it used to be a rule-based scenario and recommendation, but using the AWS technology, we have this personalized service. And based on machine learning, we're very good at making recommendations on the basis of personalization. So by using personalized, shopping cart conversion rate grew hugely. And all the recommendations are made by machine learning of AWS. The second trend is smart product based on DT. That's the second trend. In the past, it was more about provision of simple products, but now customers have higher standards and they want to have distinguished experiences. And in the case of B2B customers, it's not just about provisioning hardware, but it's about total solutions and management solutions. So product as a service or providing smart products have become important. So the best example is the case of Carrier. This is the company that developed the AC for the first time, and it announced that it would introduce a cold chain business. If you look at the background, 1/3 of food produced around the world is wasted and discarded before it is consumed by consumers because companies fail to manage temperature of this food. And there are many people who are suffering from hunger, and that's the economic loss of 1,000 trillion a year. Same thing applies to medical products. For instance, you must have been vaccinated against COVID-19, and let's say that there is a vaccine by Pfizer, and it has to be managed under certain temperature, otherwise it will go bad. So before it is vaccinated, many of the vaccines and medicines are discarded because they fail to manage the products at proper temperature. So we're working closely with Carrier for this cold chain management. And across the value chain, end-to-end visibility tracking is enabled by links. For this tracking, of course, we are utilizing the IoT, machine learning, big data. These different technologies are used so that different use cases are reflected in the solutions. For instance, when you deliver products, fridged products, then you have to turn on the cooling devices. But if you turn on the cooling devices too early, then that would lose too much cost. So it's really about finding the right time to turn on the system. And across the platform, it identifies the location of food, traffic conditions, and it estimates the time of arrival so that cooling devices can be turned on and used at the right time. And throughout the cold chain on the right-hand side, you can see the picture of a vessel. They use vessels, and within these ships, they have cooling systems. Before they break down, we have this predictive maintenance system. So when the systems break, we know how to deal with these failures. Next, in the field of R&D, in terms of time to market revolution, we are doing our best to make a contribution that led to success. Automation, autonomous vehicles, these were the topics that we looked at. And in the case of Toyota, BMW, these are automotive companies that use ADAS solutions and autonomous solutions. And based on the AWS systems, they can do their simulations faster. And in fighting COVID-19, Moderna and Pfizer, in their clinical trials, AWS provided huge support, and also simulation was greatly reduced in terms of time for semiconductor companies. So that's how we can utilize this technology in R&D. So the case in point is MediaTek, which is a Taiwanese company. The smartphone that you have or the smart TV that you have, I believe that you have some component from the MediaTek. So if you look at the semiconductor process, it's expressed in nanometers. So from 40 nanometers, now it's reduced to 7 nanometers. From 40 to 7 nanometers, the design complexity increased, and the intensity of transistors increased by 17 times. Transistor density increased by 17 times. And the simulation tool that is called EDA, the number of EDA jobs increased by 10 times, and the servers increased by 15 times. As you can see from the picture below, even if you make predictions, well, R&D has a lot of uncertainties. So when we have lots of simulations happening at the same time, then the simulation process is delayed, and that leads to a delay of a time to market. So at MediaTek, regarding the capacity for simulation, regarding how R&D can have fluctuations, we provided a solution of combining public cloud to go for hybrid cloud. Next one in the field of manufacturing. Well, partial optimization is done very well by many companies, and when it comes to global manufacturers, by site, by location, well, some of the fields for yields, some of the figures for yields are in the 90-something range, but it's not always that high in other parts of the world. So under the cloud environment, by combining machine learning and data, big data, we can optimize yields, predictions, and quality inspection so that we can optimize the overall process. So the case in point is Volkswagen. It's one of the biggest manufacturers in the world, and it was suffering from the same issue. It has 122 factories all across the continents, and it has more than 1,500 partner companies. So they had a lot of issues regarding the overall optimization. And it worked with AWS. And now, with AWS, it is developing the industrial cloud project. And it is moving data to the public cloud of AWS, and with the combination of machine learning, predictive maintenance, yield optimization, OEM, and quality inspection solution can be secured, and also Volkswagen App Store is being built. And this can be loaded onto the group App Store, and predictive solutions from 12 factories can be uploaded onto this, and these can be referenced by the rest of the factories if they're working well. And in operations, we also have a good example of the cloud. This is a case of Enel in Europe. So it's an electricity company. And as there were many natural disasters, including floods and so on, it has to be prepared to respond to these disasters. So what it did was to add high-tech sensors to substations. And that was to increase flood predictions and ozone monitoring. And under the public cloud environment, they did the machine learning to train the model. So, for instance, if the sensor senses this, that means there is a flood. And this predictive computing is delivered to the substation, and we make sure that there's no latency. And if there's a flood, then from the main SCADA system, it cuts off the adjacent substations. And if there's a burglar, then we can send the security personnel from a close-by area. So that was a quick introduction to success cases of our customers. And for those companies that are successfully going through DT, have these commonalities. So it's not like they are approaching this technology and they want to just experience this because there is a new technology in the market, but what they do is that they understand the pain point, and they analyze this pain point, and they develop use cases. And second, how do we start DT? I believe it's just like when you start a new business. When we start a new business, we look at two things. First, how attractive is this? So how big is the market for us? And how well and how feasible are we in the market? So I believe the same concept applies to DT. First, what will be the area that has the greatest impact? What is the area that is most attractive? Second, feasibility. What is the area where we have the biggest data? So you might want to choose that particular area to have initial success. And third, like I stressed before, this DT cannot be successful if it's led only by IT or just one single team. It needs collaboration from OT as well, because operational teams are the ones that know the business very well. So you have to work closely with OT to increase the possibility of a successful DT. So that is the end of my presentation. I hope you can enjoy the rest of the session as well. Thank you. Thank you very much for the great presentation. Mr. Lee Hyun-sok of AWS, please thank him with a big round of applause. Through DT, in recent days, we're covering lots of topics. And it's not just about digital application that we can refer to. And they can provide some convenient and promising business opportunity. But once the business grows, how can you control and manage this growth? So that is something we need to consider as well. DT based on big data and how this can be collaborated with the support of the cloud. This is what he touched upon. And that collaboration is what we are seeing currently. So when ICT platforms are developed and when these platforms are applied and implemented, well, we need details. And also, when these are applied to our businesses, we also have to think about how much business impact it can create. So thank you for touching upon these elements. And also, what resonated with me was, well, one of the misunderstandings that we have is when a digital platform is developed by an expert, then the expert might think that he has the best product ever in his field. But unless we secure cooperation with the industry, then that product would not produce any results. And his message was about how we can work together with ICT experts and industrial experts. So I'd like to thank Mr. Lee for his great presentation, and a big hand for him, please. So with that, for this session of shipbuilding and maritime transportation, we had track 1, decarbonization, track 2, DT. From these 2 tracks, I believe that we covered very comprehensive elements of shipbuilding and marine transport. And these were very meaningful tracks that provided us with future directions. So with that, I'd like to conclude track 2 DT session of the 16th World Ocean Forum. And I'd like to thank all the presenters, Mr. Kim, Senior Scientist Onot Yan Rotsef, Dr. Yeon, and Project Head Kim, and Head of Business Development Lee. I'd like to extend my gratitude to the participants as well. And this is the end of track 2. And I'm going to meet you back in track 3, which is a wrap-up session. Thank you for your attention and for your insights and presentations. Thank you.
Thank you very much. I would like to thank Mr. An for moderating the digital transformation session. Thank you. And so we have heard all the presentations prepared for the decarbonization and digital transformation sessions. And after we set the stage, we will have a wrap-up session in the form of panel discussions to look back on the 2 topics. We will have a short break, and we will see you shortly. For those of you on site, we have coffee ready in the hall. Please enjoy your break and come back here for the wrap-up. Thank you.
네, 잠시 후 저희 랩업 세션.
The wrap-up session will soon begin. I'd like to ask the participants to please come inside and be seated.
Wrap-up session. So please come inside and take a seat. 네, 그리고 본 행사는 한영 동시 통역이 제공이 되고 있습니다. 혹시 통역이 필요하신 분들께서는 앞에 놓인 수신기 사용하시면 되고요. 한국어는 1번 그리고 영어는 2번으로 맞춰주시면 되겠습니다. We provide simultaneous interpretation for this forum. If you need interpretation, you can use the receivers in front of you on the table. Turn to channel 1 for Korean and 2 for English. Thank you. We will get started really soon. 네, 그럼 이제
And now we will start the wrap-up session. So for the first half of today, we discussed decarbonization this morning and digital transformation just now. And now we will invite ocean experts for an in-depth panel discussion. And before we start, let me introduce the moderator. We have Mr. Kim In-hyun, professor at Korea University School of Law and also a captain. Professor Kim is already on stage. Please give a warm hand to Professor Kim. Thank you. And now you have the floor. Good afternoon. I am Kim In-hyun, professor at Korea University School of Law. I teach maritime law. At this World Ocean Forum, I am a member of the planning committee. In track 1 and track 2, we discussed decarbonization and digital transformation. We had excellent presentations. I would first like to thank the two moderators of tracks 1 and 2. Professor Lee Yeon-seung and Mr. An Kwang-hun. Thank you very much for moderating the tracks. As you know, 2D, the decarbonization and digitalization, have become the constant coefficient in this industry. They have taken root deep in the ecosystem of the industry, and as you can see in the room, we have many business participants, business sector participants, and I felt that 2D have really become a true part of the value chain of this industry. And with regard to these two sectors, there have been many presentations made and papers issued, but at the 16th World Ocean Forum, I think this is a very nice forum to look at the real case examples and real world solutions. I have already learned so much from the insightful presentations, and from President Shin Dong-sik, he gave us a very detailed explanation about the CCUS technology. And now we will have a panel session. First, we will start the discussions on decarbonization first. We have 10 panel discussants today. We will start with the decarbonization. Let me introduce the panels who will discuss decarbonization, and then we will move on to DX. First, we have Mr. Baek Jong-hyuk, Senior Vice President for Nuclear R&D Strategy and Planning, Korea Atomic Energy Research Institute. Please give a warm hand to Mr. Baek. And next, we have Director Lee Hyun-ho from Hyundai Maritime Research Institute at the Hyundai Heavy Industries. Please say hello to the audience. We also have Ms. Madeline Rose, Climate Campaign Director of Pacific Environment. We also have Mr. Jin Kyu-ho, Vice President of Management at BPA, who also gave us a presentation this morning. And online, we also have Mr. Stavros Hatzigrigouris, Marine Consultant and former Managing Director of Maran Gas Maritime. So the panels have 5 minutes each to discuss the presentations and to also give your comments, as well as to share your views. Starting with Mr. Beck, please.
예, 반갑습니다.
Good afternoon. Well, this is not the field I'm quite... Well, it's great pleasure to join you, and not all of you share the same issues. In the nuclear field, I've been working in this field for 30 years, involved in developing nuclear reactors, and we made an export to the UAE, APR 1400, loaded and ready. That's what I developed when I first joined the Korea Atomic Energy Research Institute. So I'm mainly responsible for developing nuclear reactors. So I'm not the best expert in the field, but whether it be maritime or nuclear, I believe that we have similar challenges. When it comes to nuclear power, it's about creating energy. And how to utilize this energy is, of course, one of the things that we think about. And in terms of space and maritime, well, it's in line with the issues that you have. And stable supply of energy was a big topic. And now the topic is moving towards the utilization of this energy that is provided. So we have this keyword SMR in nuclear. I believe many of you heard this term in press coverage. So compared to previous reactors, well, it's about flexibility. Using nuclear power, how can we produce hydrogen, and also how it can increase processes and create power sources using nuclear. We have thought about it for a long time, and how this can be applied to maritime is one of the things we can think about. As the chair said, 2D, which is DT and diversification, were among the 3 Ds. So DT and diversification can be seen as another 2D. And that is related to nuclear. And I believe that that would be linked to the first step of maritime, whether it be electricity from nuclear power, whether it be thermal power, whether it be power generation. Well, for more than 2 decades, we've been working on how this can be utilized. And this is actually the application of this technology to maritime to be net zero. And all the collaboration work already started. We had a presentation of the head of CRISO. And in nuclear, we already started to work with major shipbuilders, 3 major shipbuilders in Korea, including SHI. And we are working on specifying our projects and how nuclear can be used as an energy source. And on the basis always is this concept of net zero. Reducing CO2 while transporting goods and cargoes to the 5 oceans are one of our top priorities. While doing so, well, I was on a business trip to Canada 2 weeks ago. It's an SMR regulation forum, SMR law forum, jointly hosted by Korea and Canada. And in North America, there are more than 70 startups that are responsible for nuclear power. And what they want to do is to reduce CO2 using nuclear to provide energy sources. It's not just about electricity generation. And in Canada, well, starting from next year, they're going to have carbon tax or carbon levy. and it's about 30 Canadian dollars. And that will increase by $15 every year to become $170. And what they want to achieve is to replace it with nuclear power. And also, there is this chemical factory that produces methanol. They want to have the nuclear power. And we are also working on how we can reach 5 oceans without producing CO2. The Ministry of Science and my organization, with the funding of national budget, are moving toward this direction. So before we reach 2030, we want to make sure that we produce some tangible results and make contribution to net zero. And we are working on this technology very hard. So thank you for the opportunity. Thank you very much for the great message. That was very straightforward. So nuclear power can be used as fuels for vessels to achieve net zero. Thank you.
Next, we have Director Lee Hyun-ho from Hyundai Maritime Research Institute. Good afternoon. As introduced, I am Lee Hyun-ho. My area of expertise is shipbuilding engineering, and I have, since graduating university, I've been working at the shipyard. And this morning, during the decarbonization track in the shipbuilding sector, there were some relevant contents on shipbuilding or marine and transport. And this afternoon, we discussed digital transformation, which also was relevant to decarbonization. So Mr. Kim Jae-yeon also mentioned earlier, and I couldn't agree more. This is the first time in my career in the shipbuilding engineering that I see such a sea change in this industry. And shipbuilding engineering is a very important academic area for shipbuilding, but this discipline faces the largest crisis ever because although the ship stays the same, everything that goes into the ship, the equipment and machinery are changing very dramatically, and all the control systems accordingly. So in the shipbuilding industry, it is very difficult to respond to such challenges. But nevertheless, globally, decarbonization is the trend that we cannot reverse. And so we are making our own preparations. And as we heard from the SINTEF presentation from Mr. Rotzeth, there's the uncertainty that comes from regulations. And cooperation with other entities are very important. And the topic of this forum has the word cooperation in it. So what will happen with future regulations remain uncertain, and we need to explore different types of technologies and also consider what type of technologies that our clients want, because there are many different types. And for us, businesses that need to serve the needs of consumers, we need to consider every possibility. But how to efficiently allocate the time and human resources to do all this while differentiating ourselves from competitors. Well, all this cannot be done by a single company alone. So we need to work with other partners. And there can be different types of cooperations. There can be a government-led project. There can be business-to-business cooperation. And through such cooperations, individual businesses, also need to work on how to reinforce their own competitiveness. So to what extent do we work together, and to what extent do we differentiate ourselves from others? Well, that's a very, very important point and will become more important in the future. So on that front, we heard relevant and important presentations today. And with regard to decarbonization, the president from Mr. Hatzigoris mentioned the LNG, that the LNG still remains the main fuel, and I agree. And when I discussed this with the ship owners, they all agree that LNG is a proven technology, proven fuel, and we already have a well-established supply chain for LNG. And we can add more technologies to the existing LNG system to respond to the regulatory changes up until 2030. But for net zero, what more do we need? That would be the main question going forward. I think that the technologies are still there. The existing technologies and the upcoming technologies are all really based on what is already here. So the CCUS technology was already around for decades, but the key is how to commercialize it and how to universalize it, and that is really about more of an economic problem. And if you look at new regulations coming out of the EU, I think the regulation is moving towards ensuring economic viability, imposing penalties and providing incentives. Is really to make sure that technologies that were not competitive can become more competitive and more economically viable. So in that sense, regulation will be needed. But I don't think that a single solution will dominate. Right now, the diesel-based diesel has been the main fuel for ships for decades. But going forward, I think we will see a more variety of fuels, whether it's LNG, H2, or methanol, or ethanol. The problem is whether we will have the right supply chain and who will provide the optimal logistics services to that supply chain will be the main game that we will be playing. And Korea has been and is a shipbuilding powerhouse, but not yet a shipping powerhouse. But I do think that Korea can have the right infrastructure to become a shipping powerhouse because Korea is a peninsula and Busan, the city of Busan, is one of the top 3 or top 2 global ports. And on the other hand, in terms of cooperation, we do need to work more because we pretty much work on our own. And in inducing and incentivizing cooperation, I think the government has a role to play by organizing different parties and providing the right framework and also enabling a nation-to-nation international cooperation with the right set of supports. And the basic technology and infrastructure also need to be funded by the government through government-led projects or research institutes. And if that can happen, I think that Korea has the right potential to become a shipping powerhouse. And of course, I understand that the Port of Busan is working to bolster its marine and shipbuilding industry. But for that to happen, we need a strong financial industry because otherwise we cannot compete globally. And so the shipping and shipping finance, ship financing industries, if these industries can receive the right support, I think that since Korea is already a leader in shipbuilding, we can lead the world. So I am deviating away from the topic of decarbonization, but decarbonization will take time and cost and cooperation will be enabled by the government support. Thank you. That was Director Lee Hyun-ho. In relation to technology, LNG is the main fuel. Ammonia, methanol, and hydrogen are technologically available as ship fuels, but Korea is lagging behind somewhat in terms of shipping, so government needs to provide the right support so that we can become competitive in this path towards decarbonization.
Next, Dr. Jin Kyu-ho from BPA. Would you like to say a few words? Well, you already delivered the presentation. And listening to other presentations, if you have any additional comments, then you can talk about them. Good afternoon. I'm Jin-Gyu Ho from BPA. This morning, I introduced you to the BPA projects, and I thought that this might not be in line with the topic, decarbonization. But at BPA, in the process of decarbonization, while reducing CO2, well, what we can use is electricity and LNG. And with that in mind, we have strategies. And when it comes to vessels and equipment for loading and unloading trucks, I covered these points in terms of decarbonization. And in order to build CO2-free ports, well, LNG generates CO2, but much less compared to diesel or fossil fuels. Electricity also uses fossil fuels, so we can't really say that it is CO2-free. The Korean government has this project for 2050 for decarbonization vision, and we have this hydrogen port included in the vision. So in the morning session, we looked at shipbuilding and marine transport, and what we have to think about is what fuels we're going to use, and depending on our choice in building our bunkering base, depending on the fuel type, if LNG is the big trend, then we have to build a bunkering base to meet that requirement. And if it's ammonia, then we also have to build the base to accommodate ammonia. So it really depends on how we decide on the types of the fuels. And in port of Busan, in order to be net zero by 2050, producing electricity internally and to be energy independent, I believe that we have to secure that capability in order to achieve true net zero and to be competitive in the long term. So by 2050, reduction of 70%, and for all diesel cars will be changed to LNG, and also they will change to DPF. And in order for that to happen, we need alternative fuels. Hydrogen charging stations are one of the things that we are considering. And with the development of alternative fuels, we believe that we can utilize these fuels to be net zero port. Starting from this May, we're working with experts to be net zero in the field of shipping, in the field net zero, in order to be net zero ports by 2050. And we're working closely with major ports around the world so that the port of Busan can play a leading role in this effort. Thank you. Thank you very much, Mr. Jin. Listening to your presentation in the morning, what was impressive was, well, regarding the yard tractors and unloading and loading devices, well, how these can be switched to be more eco-friendly. And that's in line with the government policies towards hydrogen ports. So once we decide on the types of the fuels for the vessels, then we can come up with ways to transport fuels. So that was very impressive, and it is a promising insight.
And now I would like to ask our two international speakers to take the floors. We have Ms. Madeline Rose from the Pacific Environment. You have the floor.
Thank you so much. Well, thank you all again. Thank you so much to the Ministry of Oceans and Fisheries, to the Busan Metropolitan City, to Busan Port Authority, to Kami, to everyone in the planning committees, again, for welcoming Pacific Environment this year for our first World Oceans Forum. We've been so impressed and so inspired by the leadership, the commitment to zero carbon, zero emission shipping and ports, and just the innovation and leadership that we've heard in the last 48 hours from CRISO, from HMM, from the Busan Port Authority. I really think you have more electric cranes on your port than anywhere in the world that I've seen so far, so it really has been tremendous. Because I have a global mandate, so I run a 15-person climate team that works on shipping and ports around the world. We cover, California policy, United States policy, International Maritime Organization policy, G20 policy. We kind of cover it all. So I thought perhaps the most useful thing I could do is provide some thoughts and comments on the trends that we're seeing outside of Korea, just to reflect on what we've heard today. So the first kind of trend that I didn't hear a lot about, but I think is really exciting, is the trend towards zero emission ferries and zero emission harbor vessels and zero emission short sea shipping. So to start the technology transition, we don't have to only talk about the Trans-Pacific or the transatlantic, but really starting with the vessels that we can electrify and focus on those. So in Norway, they're planning to have a zero emission zone in the Norway fjords, their marine protected area, only zero emission ferries by 2026. It's just around the corner. In California, we have a new mandate for zero emission short run ferries in 2025. And just today I learned that the Busan Port Authority has many passenger ferries that are electrified that will be on the water as early as next year. So really committing to electrifying all of the small vessels that we can is an exciting trend that we can focus on, and somewhere where Busan, I think, can lead and show the world. The second trend is a focus on zero in-port pollution. So many colleagues this morning talked about Fuel EU Maritime, but they were focused on the fuel uptake mandate and the sort of long-range greenhouse gas targets for big shipping. But the Fuel EU Maritime bill also has an in-port pollution standard that is modeled off of California's port pollution standard, which China also adopted. So that means it's a requirement that all ships that will call European ports must plug into shore power by 2030 or must otherwise be zero emission. So that's really going to catalyze the shore power market, or alternative marine power market, basically more electricity in the ports, but cleaner air and healthy communities for port residents. So it's a really important policy where I think, from what I understand, I don't think Korea currently has a zero emission port pollution commitment, which I think could be a really great place for additional leadership. Third, on the greenhouse gas targets for the big ships, I often say the big kahuna, the big ones. A lot of colleagues this morning mentioned the existing IMO targets, but I just think we should all be clear and honest with ourselves that those targets are soon to be irrelevant. We expect that the IMO is going to pass an amended strategy next summer, June 2023, under Secretary General Ki Tak-lim's leadership. Hopefully that will be requiring 100% zero emissions, 100% zero carbon. We hope 100% zero carbon equivalents, but we'll see, by as soon as June 2023. So the initial ambition of the policy mentioned this morning is really just the floor. All of that is to say we are going to have to go faster. For the global shipping industry to do its fair share for reaching the global carbon budget, the entire industry actually should be much closer to zero carbon by 2040, not 2050. Of course, 2050 is a great start. I used to work in government. I understand you have to start somewhere. So starting with 2050 makes sense, but we do need to be honest with ourselves that even zero by 2050 would not be aligned with a livable world of, really trying to mitigate 1.5 degree or 2 degrees Celsius of warming. And then, on that front, just want to, comment that we do have we run a campaign called Ship It Zero. There's cute little personified stickers out in the lobby, smiley ships, they're very cute. But that is a campaign focused on accelerating the zero emission vessel market. So through that campaign, we've worked with Amazon, IKEA, Target, some of the world's largest companies who have committed to zero carbon ocean shipping by 2040. And they really are looking to partner with shipping companies like HMM that can offer them the best, fastest, zero carbon commercially available option. And they're really willing to, use their market power, stick their necks out to help create this market demand and realize the zero emission vessel market. So those are a few reflections. We have a new campaign, which is one of the reasons we're here, which is called Ports for People. There's, again, some materials out there, and happy to talk about that more, and happy to talk about LNG more, and why we disagree that it's the fuel for the future, since it is a fossil-based fuel. But I will save that for later. Thank you.
Thank you very much, Ms. Madeline Rose. You mentioned the decarbonization regulations on large vessels is important, but it's nice to work with the small vessels such as ferries. And also import regulation will be also important. You shared some case examples, and at the end you said that LNG may not be the answer. Thank you.
Next online, we have Mr. Stavros Hatchgrigoris from Greece. And now the floor is yours.
Thank you very much. Good afternoon. Good afternoon, everybody. Thank you for the invitation. My topic was LNG technology. I believe LNG technology has leaped forward quite a lot over the past 20 years. It's the only sector in shipping for which the technology has changed a lot. This was part of my presentation. I understand that LNG is a transit fuel, but there are other projects about green methane, green LNG, green methanol that may help to move towards the zero carbon, zero emissions target. There is a project going on now. It is involving one of the Middle East countries. They will import LNG. They will split the LNG in hydrogen and CO2. They will capture CO2. This is going to be green CO2. The liquid CO2 will be transported to Europe and mixed again with hydrogen to produce green methane. This is a technology that, and it's not only about methane, this is a technology that we should be careful about, focus on it. If you read the International Energy Agency report, you will see that they say that even by 2050, there will be plenty of fossil fuels around. And the solution to move towards decarbonization is to capture the CO2, make it liquid or make it lime. There are about 20 companies now working towards carbon capture, and then sequester the CO2 or use it to produce green fuels, as I said before, green methanol, green LNG. I believe the LNG industry is very, very important for Korea. Korea is the leading country for LNG ships construction. The technology is also changing there. Shipyards are booked until the end of 2026, and some ships will be delivered in 2027. Korea has to be careful not to lose this industry toward China. Recently, there have been at least 4 Chinese yards that have never been involved in the LNG industry before, and they have received orders. To conclude, the LNG will be very important for reducing carbon emissions until, let's say, 2035 maybe. And then we have to look for a different technology. And in this respect, I believe carbon capture, liquefying the CO2 and sequestering will be very, very important. As per the IEA report, 40% of the CO2 produced by fossil fuels in 2050 will be captured and sequestered or used, as I said, to produce green fuels. Again, thank you very much for the invitation. I'm sorry that I could not come to Busan this time, and all the best to everybody. Thank you very much.
Thank you very much. Thank you for the great message and for the great conclusion. Using LNG, well, we can use this technology, use this fuel for quite a long time. And regarding the CO2 that is generated, well, we can utilize CCUS technology. It can be liquefied and it can be utilized, captured. And in Korea, well, how Korea is leading the shipbuilding in terms of LNG. So let me once again thank you for your remarks and insights. Thank you very much.
예, 일단 우리 토론.
So we are halfway into this panel. Those of you participating online or those of you on site, if you have any questions about decarbonization, please submit your questions so that I can deliver those questions to our panelists at the end of today's track. And moving on to digital transformation. We have had very specific case examples shared with us during this track. In particular, the effects of digital twins. I think we heard from the BPA, 5 case examples were shared, and it was a very good learning session for me, and I felt the urgent need for this. And from AWS, you shared good ideas about the cloud technology, and I was able to feel that digitalization greatly helps our daily lives. And based on the presentations given today, I would like to invite the panels for their comments. Let me introduce the panelists first. We have Mr. Nam Young-soo, CEO of Value Link U. Please say hello to the audience. A member of our planning committee, Mr. Oh Soo-han, Professor of Department of International Logistics at Chungang University. We also have, from the government, the Ministry of Oceans and Fisheries, we have Director Hong Geun-hyung for Smart Shipping and Logistics Team. And our presenter, Mr. Ornolf Jan Rosseth, Senior Researcher Scientist of SINTEF Norway. Mr. Nam, would you like to begin? Hello, I am Nam Young-soo from Value Link U. With regard to digital transformation, we were able to hear technologies and real case examples. Smart ports, smart ships, and cloud services, digital strategies were the 4 main parts of what we heard today. Digital transformation not only in shipping and shipbuilding, but in many other industrial sectors. There have been many different presentations made, and I think that you have become somewhat familiar with the topic. Rather than summarizing the presentations, I would like to share with you my personal comments based on the presentations. those of us preparing for digital transformation, do we go from outside in or inside out? That's the key question. Many digital technologies are not recent. They have been in place for 20, 30 years, and they continue to evolve. So do we use this technology to cut costs and raise efficiency? That would be one part. And another part would be to develop new businesses and services to transform the business with digital technologies. So that is another big part. So I think today's presentation really focused on the inside-out strategy, which I think would have been better if we heard from the outside-in technology as well. So what does it mean to do an outside-in tech strategy? Well, this may be overlapping with the earlier presentation, and we also heard from Ornov from the outside-in approach. So when you think of eco-friendly ships, you might think that it'll be very quick for us to reach net zero, but that's not the case. There are existing ships in operation as well, and there are two main drivers. One, service providers, the shipping companies, and secondly, the consumer group of shippers. But do you know whether shippers are using eco-friendly ships or not? It's the same for the carriers and for the air cargo. Clients do not know whether the plane that they're riding are SAF attached or not. The shippers don't know either whether the ship that they are booking is eco-friendly or not, and same goes for air transport. If the shipper knew, then they would try to prioritize the use of eco-friendly ships. So this is where the seller and buyer needs to work together. And if we were to enable this with digital technologies, well, of course, Green Cargo Working Group is providing some of those relevant technologies, but what they do is they just provide the average information rather than being specific as to which ships are eco-friendly. But of course, starting next year with CII coming into play, then that will be a different story. But for all the inland shipping and the ocean-going shipping, if I were to use 20,000 TEU grade vessels, how much carbon have I used and have I emitted? Well, that is managed under Scope 3, but under the Green Cargo Working Group, you are given a sum of each ship, so you do not have a specific data. So for each ship, we need to have the specific cargo emissions, truck cargo emissions, warehouse emissions, and port emissions, and put that all together for booking services. This was not available before, but digital technology platform and data will make this possible. Eco-friendly is therefore impacted by digital transformation, and digital technologies have a role to play in eco-friendly areas. And single window is a very important part you heard today earlier. You think about inside-out strategy of using these technologies, but it's a very high-risk type of business. Ports have ship data and developing digital twins. Well, that can be very high risk. Autonomous ships, when you do not have the data on other types of ships and ports, just developing autonomous ships without any of those relevant data at your hand, it will be quite high risk. So in the end, you eventually see a single central point of concentration. And in that sense, single window is a very important platform. It is an integrated data platform, and through standardization, when there's data transaction, you can also analyze that data. And all these relevant technologies are at the basis to support autonomous ports and ships going forward. But this is not possible because data is not available. Nobody wants to share their data. So what can be done now? Our company's example is that we create a automated data first, and we purchase the relevant data and share the data and in turn get the data from others and build new data based on that and continue the exchange. So after playing the virtuous role, we can then expect more technological development. So going forward, digital strategies, well, we hear a lot about the need for building a platform. And you might think of a commercial trading type of platform, but going forward, in particular in the ocean sector, platform will be more of an SG and management and data platform rather than commercial. And plus, there will be digital technologies attached for big data analysis, AI, quantum technologies for automation. So next year, maybe we can look into these case examples to share insight from that perspective. Thank you. Thank you, Mr. Nam. I'm not sure if I understood your comment because that was quite technical. He is a digital expert. So inside out, rather than inside out, based on the individual perspective, outside in is more of the strategy that we need. So you need to share your data and engage in data exchanges for public good.
Next, Professor Woo Soo-han, please. Good afternoon. I'm from Chungang University. Throughout the day, we talked about shipbuilding and marine transport. So having this integrated theme is indeed meaningful, and this is our first, actually. I learned so much from today's sessions, and also especially when it comes to autonomous technologies and how these are being developed. Well, it was really interesting to see this technological development. So we looked at many presentations and new technologies. But on the other hand, I thought that there is kind of a gap. And as I teach students, I would like to talk about talents regarding DT. So in a narrow sense, DT can be interpreted as business transformation, creating new businesses using a hardware. But today, DT we talk about is about exchanging objects between objects and single window, collecting data, creating data, and sharing this data, having such infrastructure. So that was more of a focus today. And if you think about the business that can be created out of this, well, you can think of shipping companies. And when it comes to DT, what are these shipping companies doing? Well, not much at the moment. Well, in the case of spot freight for containers, well, selling spot freight is pretty much where we stand at, and not really going beyond that. Still, top 10 container shipping companies, this is what top 10 companies are doing, and that is actually less than 5% of the total revenue around the globe. And if you think about the relationship between shippers and VLCCs and carriers, what that means is that we are seeing an expanded channel for the shippers and for the shippers to meet the carriers. So from this perspective, the shipping companies in terms of DT can identify the characteristics of different shippers and what searches are done by these different shippers at what prices, and based on what behaviors. And on the basis of this analysis, well, we can create services and provide services to meet their needs. And this is related to CRM. Market conditions can be reflected, and additional services can be provided based on this information. And using these platforms, we can expand the existing businesses. So that's how we can approach it. To do that, the organizational structures of shipping companies and their personnel, well, they have personnel for shipping, for sales. Well, can these personnel cover all these activities with these new service platforms? And when shippers make purchases and there is an upsell opportunity, and we might want to give some recommendations to them so that this can lead to an upselling. And this is what we can utilize the case of Amazon, where it recommends a personalized service. For that, we need different knowledge of domain, shipping, data logistics. And do we have talents that have all this knowledge? So that's one of the issues that many shipping companies are faced with. One of the Asian shipping companies, it's a middle-sized company. It wants to pursue DT, and the company was very angry at me because I'm teaching logistics and I cannot nurture any talents, but still I'm telling them to employ students from this field, and this company is only employing students from engineering majors. The talents that we need are the ones that have data analytics knowledge. And starting from the undergraduate courses, logistics, shipping, data analytics, DT, all these elements have to be reflected in the courses so that we can develop right talents. And for the last 5 years, this is what I was working on as well. And on the government side, when it comes to shipping and shipbuilding, when it provides support for these sectors, well, it does provide support for R&D and other fields. But when it comes to nurturing talents, well, this is something that we are not really keen on at the moment. So we are talking about DT from the business perspective, and I wanted to highlight the importance of talents. And also, related to decarbonization, well, we looked at autonomous vessels, alternative fuels, and so on. And we had lots of discussions based on IMO regulations. But from shipping companies' point of view, once we comply with all these regulations, then does it mean we meet all the requirements by our shippers for CO2 reduction? Renewable energy 100% is something that we are pursuing, but that is excluded in the ESG strategy. So if we stick to, or if we are only paying attention to IMO regulations, then is it sufficient enough to meet the requirements of shippers? I don't think we had active discussions on this point. Yes, we do look at IMO regulations, but we have to look at the supply chain as a whole, and we have to have a sense check as to where we stand. Thank you. Yes, Professor Wu, thank you for the insight. He teaches business management, so I believe that he, through a fresh perspective, I also teach maritime law. So I agree with many parts of what he said. And when it comes to the platforms that we are developing, using these platforms, where shipping companies and shippers can meet. Currently, MVOCCs and forwarders are in between. So currently, we have these parties in between, and going forward, the presence of forwarders will be removed, and the shipping companies would directly talk to shippers. So that will be a major change in the future, which he brought up also nicely. And also, we have to have knowledge of domains, logistics, and all the relevant fields. And we have to nurture talents with that in mind.
Next, from the MOF, I'd like to invite Director Hong Geun-hyung to take the floor. Good afternoon. I am the Director for Smart Shipping and Logistics team of the MOF. My name is Hong Geun-hyung. I'm listening to the presentation from experts. I was able to learn so much. And from the government's perspective, being a part of a forum such as this is to understand the trend and to reflect what is heard and requested here to into the policies. I would like to share with you the MOF policies and what kind of efforts are being made. The MOF in 2019 set up the strategy to build a shipping and logistics platform. And in 2021, Smart Logistics Development Policy. And last year, Shipping Marine Innovative Regulatory Roadmap has been set up. So in the mid to long term, we do have a roadmap in place. Port automation, smart port infrastructure, smart ports, connecting the logistics inland and offshore. Under these missions, we have 11 projects. 400 million won of budget is in place. And at the Smart Shipping and Logistics team, we look at the autonomous ship research and development. I think this was already presented by Dr. Kim Jin. And not only technological development, but preparing international standards and setting up the domestic legislation accordingly is where we also work. For autonomous ships, this is a new type of system. So we do need to review the relevant legislation, and when the ships are fully validated, they need to be commercialized, and all this process will need legislative support. So we will enact new law in terms of allowing for a special treatment of autonomous ships in terms of validation and commercialization. And for autonomous ships, as you heard from the other presenters, there is the international standard in place, and we need to contribute and lead the way in developing standards by taking full participation at IMO meetings, and we are doing just that. And with regard to smart ports, we have a automation testbed in Gwangyang Port. And for the first time, we want to automate the full port. And we will be using domestically developed equipment and many different types of new technologies. The fully proven and demonstrated technologies will be used to Junhae Busan Port to become the world's smartest port. And this remains to be seen. And so at the World Ocean Forum, I hope in the future we will have an opportunity to make a relevant presentation. And as the professor has rightly pointed out, once smart digital transformation takes place, there will be a large pool of talents in need. We need to train them well and for them to find the right jobs and to transition their careers. So a practice-based education and training program and career change program will also be offered to develop a pool of talents and also to address the existing problems. Along with decarbonization, digital transformation are very important issues. Well, smart digital transformation is already fully reflected in the national policies and projects, and we will continue our efforts on that front. And it is a great opportunity to be here to listen to the trend and to reflect your needs into our policies. Thank you. Thank you, Director Hong. You shared with us the government efforts on digital transformation and decarbonization policies. You mentioned the automated port testbed in Gwangyang Port. And as Professor Wu has mentioned, you also gave your positive comment on developing a pool of talents. Next, Senior Scientist Onopian Roseth, please.
Sorry, get rid of that. It has been an interesting day. I think the first session really showed us the problems we are facing in decarbonizing shipping. It will be a big challenge. But as yesterday's prize winner said, challenges also mean opportunities and innovations. And after innovation, there may also be disruption. I'll come back to that. I think, again, going back to the problems we have with decarbonization, we have talked about fuels, hull structures, and so on and so forth. But my special interest is, of course, making the whole supply chain, the logistics chain, more efficient. There's a lot of things to do there, and I expect energy prices for fuel to go up significantly. And that really means that we also have to save energy if you really want to have shipping having the role it has today. So I think efficiency is in any way necessary. And that means basically automation of supply chains, logistics chains, efficiency improvements in ships, and so on and so forth. And then we are back to digitalization and automation. Part of that is also autonomous ships that was discussed also today. And in all these areas, and I'll come back to what I said in my presentation, shipping is a very small sector. It's not a lot of people working with this. And we cannot afford to compete with non-competitive, pre-competitive, necessary knowledge. Kim Jin mentioned all this problem with testing, safety standards for autonomous ships. This is not something that we should work on independently. We should cooperate. Interface standards, digital standards, and all this stuff is really something we need to do together. And this is pre-competitive. It's not a big competitive advantage to develop a standard. Using the standard, on the other hand, is the important thing. Then you can get these innovations, new products, better products, and improve your competition. And I'm from Norway, and we are willing to take up the competition with Korea. We have a very good relationship. We cooperate somewhere, and we cooperate and compete other places. But we really need to still cooperate on developing the necessary baseline for producing the new products. And the last point, which we haven't discussed at all, and I'll come back to what I mentioned about disruption. If you look at the two commercial or semi-commercial projects we have on autonomous ships in Norway today, Yara and Asko, they represent totally new logistics chains, operated by the cargo owners, not by ship owners. It's a totally new business model. Likewise, we have heard some examples of how digitalization may change business models, which again may mean disruption. We may have to think about totally new logistics transport systems. we should be aware that a lot of ship owners today, they are not concerned about transporting goods. They are concerned about selling and buying ships, which is not a really good business model for tackling these sustainable development goals and the challenges with decarbonization. So there is a real chance, I think, that we may get some more or less disruptive changes in business model in this area. So that was my observations, and thank you for a very good conference, very comprehensive, and a lot of different themes which fits very good together. Thank you.
Mr. Onofyan Rotsef. So based on his presentation, he shared with us with his insight and also the disruption that we haven't thought about and digitalization, how this can be, how this can change the relationship with shippers.
And that was it for the panel discussion on the second topic of digital transformation. And now we will take questions either from the floor or from online participants. We have a hand up, 2 hands up on the floor. Please bring a microphone. And could you please introduce yourselves and state your affiliation? Hello, I am Professor Kim Ki-seung from Busan University of Foreign Studies. 2 things. When we bring in LNG carriers and it was mentioned that we need to capture the carbon that comes out of LNG carriers, but this seems to be very costly. And where do we put the carbon? The storage of carbon is very challenging. So for zero carbon, we need to make so much sacrifice. I am very worried. And secondly, in terms of digital transformation, this is a good movement, but for shippers all the way from the warehouse to the means of transport, if all the carbon emitted in the process is to be calculated, then countries like Korea, where would see so much rise in logistics costs that in terms of shipping and logistics may lose competitiveness. And the logistics cost will go up too much to be a burden on the shippers. So I think that for a most convenient and cleanest environment, well, net zero by 2050, for example, do we really need to think that carbon is the biggest enemy of the mankind? I think that we need to be more flexible than that, because in Korea, already there are so many small-scale vessels. But there's no support given to those vessels. If we only make the investment in mechanisms, are we going to really realize green piers? We really need to think about these points.
마지막에 영세.
So at the end, did you say DWT, small DWT? Yes, I meant that there are many small vessels, such as small fishing vessels in Korea. Almost all of them use sulfur-emitting fuels, which are a large source of pollution. and I can sense that when I go walking along the shore. So for those small vessels, the government should provide more subsidies. When they provide subsidies for eco-friendly ships, why don't they subsidize these small vessels for their conversion to cleaner fuels? Carbon capture and sequestration, all that seems very distant and far away. We should be more realistic in our approach. Yes, I understand your point. So in the end, you said that for old-aged vessels, they emit more carbon and they should be converted over to cleaner fuel for us to reduce carbon. Investing in LNG, carbon capture, sequestration, desalination, we should invest in more realistic type of policies. So we will gather more questions and ask our panels to answer the questions later. We have another question.
예, 아까 김기순 교수님 질문은 우리 진규
Professor Kim's question is, maybe this can be addressed by Mr. Chin. I'm An Kwang-hoon from Hyundai Heavy Industries.
여기 3트랙 여자 패널들 분께서
The panelists from the wrap-up session shared with us their insights and remarks. And it seems like I have to extend my deepest apologies because I couldn't persuade one of the participants who just raised the question, who has doubts about the technologies that we talked about throughout the day. So my deepest apologies. And what I want to say is, well, all the panelists represent their fields. So it seems like we have three major issues to sum up. First, about CO2 reduction. We have to understand the needs accurately in building our ships. We have to understand the needs first before we talk about decarbonization. And by having digital platforms, does it mean that all the conditions are met? Does it solve all the problems? For many years, I attended conferences and meetings, and I have questions from our customers. Well, if we achieve DET, then many of the jobs will be lost. That's what they think, but I beg to differ. Well, we see DET and digitalization. And in order to support DET, we will need more high-skilled people. In Busan, we have this remote support center. And in this remote support center, we have more people than those who work at Hyundai Heavy Industries. And at schools, nurturing talents is a big issue. And many companies and businesses are considering this as well. Considering the reality of Korea compared to Europe or the US, while situations might be slightly different in these regions, but in Korea, at schools, in terms of decarbonization and DET, they have to be preemptive in developing their curricula. But actually, businesses lead the efforts and schools are following the footsteps. And next, about sharing information and data. Well, data sharing platform has become a big issue, and we had lots of discussions around this in Europe as well. Currently, data is not being shared because these companies see this data, their competitive edge. So how do we persuade these companies to share data and information? That will be a big challenge.
And when it comes to data sharing, well, is it from the perspective of shippers or other parties? So it really depends on different stakeholders. And currently, we fail to persuade shippers. But when it comes to decarbonization and DET, well, we have to revisit this approach. Why do we pursue these two Ds? Regarding decarbonization, we're talking about this with our panelists and businessmen. And when we had such a discussion 2 years ago, even though Europe was very keen on developing measures and developing responses, Korea was very reluctant to handle these issues. So the two big trends in the field of shipbuilding, maritime, transport, we are seeing these new technologies emerging. So what I'd like to suggest is at schools and public agencies and research institutes, well, my responsibility, my expertise is shipbuilding and maritime business. But anyway, we have to see the linkage between these different elements, different fields, in order to tackle related issues, autonomous navigation, talents, fuels, and so on. So the reason why we're talking about autonomous navigation is because it's closely related to alternative fuels. And once we resolve the issue of alternative fuels, then there will be a huge growth for autonomous navigation. And that will change the nature of the relationship between logistics and the shippers. So we have to think about the linkage. And when we have a next forum, I actually took a note of everything you said. And this can be incorporated into developing the next forum. And also, for presenters and panelists, I believe we can share our concerns and thoughts and make these discussions public. Yes, thank you very much, Mr. An. While covering all three sessions throughout the day, you made a general comment. And based on the industry you're in, we have different levels of understanding. So these can be factored in the next forum to have an open discussion. So thank you for the great insight.
And why don't we go to the question from Professor Kim? Perhaps Mr. Jin Gyu-ho, you can take that question. Yes, I am Jin Gyu-ho from the BPA. I'm not sure if I'm the right person to answer the question, but let me try. LNG carrier and all the efforts made on that front for carbon neutrality seems too much, you said, and that if shippers are to calculate all the carbon emitted throughout the logistics process, that'll be too costly, and in the end weaken our competitiveness. And where vehicles receive so much, automobiles receive so much government subsidies, why not for smaller vessels? Well, yes, you are right. But I read a few days ago that there are 196 countries around the world, and there are 128 countries that participate in carbon neutrality because climate change is a very serious issue worldwide and the awareness is there. Then what kind of impact will climate change have? Well, the temperature will go up, which will lead to higher sea levels. And we will have an upswelling in the ocean. 20 to 25% of fisheries production will go down. And in the polar area, sea ice will melt. And in the case of the North Pole, 15%. And Antarctica, 20% of the sea ice will melt. And this will lead to corrosion of the coastal areas and erosion and inundation. So climate change will push up social costs globally significantly. That is the general consensus. And so countries around the world need to do what they can by establishing the policies at the national level. And for the digital transformation and the shipper cost, well, if in the end logistics cost is able to go down for Korean logistics companies to become globally competitive, that would be very nice. But too much cost being transferred over to the shipper will not be very ideal. But there's also the other side of digital transformation that will bring a lot of cost reduction. In this morning, we heard from the BPA, the digital twin platform was presented. The digital twin platform will reduce the cost by 15%. So digital transformation also brings a cost reduction, which may offset the higher costs in some other areas. And for very small vessels, I think the MOF is the better place to ask the question. But for old and small aged vessels, engine development, fishing vessel, aged fishing vessel, shipbuilding projects are being done by the Ministry of Oceans and Fisheries as part of the carbon neutrality roadmap. Thank you. Thank you very much. Professor Kim, I hope that was a sufficient answer to your question. Realistically speaking, in relation to environmental regulation, if we are to violate those regulations, vessels will not be able to leave ports. So ship owners must be very aware of regulations, and that's why shipyards are preparing for decarbonization. And with that, I would like to conclude the Q&A session. I would like to give my closing remarks, if I may. Oh, just one last question.
마무리하실 전에 죄송합니다.
My apologies. You were just going to wrap up the session, but I had a quick question. I'm with Climate Solution. I'm with one of the climate groups in Seoul. I have two questions. First, among 190 countries, 128 are pursuing net zero. Then regarding that, the use of coal, fossil fuels, will be reduced in our journey to net zero, so it's bound to get reduced. And shipbuilding is included in our session. And in shipbuilding, we build lots of LNG vessels. 80% of them are built by Korean shipbuilders. So with this pursuit of net zero, well, what would be the alternative, or what would be the way forward for the Korean shipbuilders? Maybe HHI can provide an answer. And regarding renewable energy 100%, Well, there can be needs for low carbon vessels by shippers. And I was wondering if the needs are really there in Korea. So I don't know who can address this question, but I was wondering, well, we have the actual needs for these low carbon vessels. Then can you quickly address the questions? Well, that was a question for HHI. So going forward, well, my understanding is that other than LNG, what would be the future vessels? Is that correct? Well, we already discussed this. Same thing applies for vessels, airplanes, and cars. If there are markets, then businesses will follow the needs. Currently, we need LNG, and that's why we have this big business for LNG. And in the future, what we can expect is CO2 capture and handling this. We are already seeing projects of handling CO2 carriers, and CO2 capture equipment. And in order to convert CO2 into energy, well, clean methanol, clean energy, hydrogen. In order to generate electricity, we can use PV and wind power. And also, we have this ocean where we can build plants. So we have many different options, and we have underwater pipelines that are being researched. So I believe that we have a huge industry. So we are not really concerned about having no business at all. Okay. Regarding the question, well, do we have the needs for low carbon vessels from the shipper's perspective? Yes, we do. Well, for shipping companies, Scope 3 is related to managing shippers, and in the bidding materials of global companies, they have to report whether they have these alternatives, and this information is included in the bidding document, and this is evaluated in the bidding process. The Clean Cargo Working Group started its activities 20 years ago, and the data that we get is average data. So for low carbon vessels or air, which need huge investments, we don't really differentiate these two, distinguish these two. So regarding the application of Scope 3, when we actually apply Scope 3, I think we can consider a buy vessel. And if I may, I would like to elaborate on the technologies. Well, in calculating the needs, well, it doesn't really mean additional costs, and it's about marginal cost. So you might think that there's a huge investment pending, but it's more about removing this marginal cost utilizing these technologies. Yes, thank you very much. So I believe this is time to wrap up. We are 15 minutes behind our schedule. From early this morning till now, we looked at decarbonization, digital transformation, and I'd like to thank you for your active participation. Well, Mr. Lee Hyun-suk from AWS, he stressed how we have to collaborate with operating personnel. The industry and IT technologies have to work together. As I teach law and Professor Wu teaches business management, we understand that having the technology doesn't always translate into commercialization or resolving issues. The society is made up of people, and this is related to the society. So in the 17th World Ocean Forum, when we talk about DT and decarbonization, I believe we can talk about business management, law, and maritime operations to find more practical solutions. So to sum up, when it comes to technologies, I believe we already have the leading technologies in Korea, and many of you would agree. Thank you once again for great discussions, and I'd like to thank all the 8 panelists. And 7 days after today's conference, well, the sessions will be shared on the website of the World Ocean Forum, so you can check this information. With this, we'd like to close this session, and tomorrow we're going to talk about ocean and maritime policies, maritime design, and epilogue. I look forward to your cooperation and support, and I will meet you tomorrow again, online and offline. Thank you.
네, 감사합니다.
Thank you very much. We never have enough time for panel discussions. Thank you very much to the panelists for your wonderful remarks and the active participation from the audience, and also the moderator, Professor Kim In-yeon. Please give another warm round of applause. As the moderator has mentioned, if you have missed any part of today's session, you have another chance to find out what was discussed a week from now on our website. This is the end of day 2, and tomorrow we will discuss marine policies, marine design, and epilogue. I ask you for your active participation. We will meet you again tomorrow, online and offline. Thank you very much.